start. طيب. Bismillah ar-Rahman ar-Rahim. I'm gonna speak in English, just so everyone can understand. Hello, everyone. Thank you for coming to our session. Our session is going to be varied, and we're gonna cover a lot of different boxes in that ultimately saves the same purpose. So, introducing Khatib and Alami first. Khatib and Alami is a multidisciplinary engineering company has been working since 1960. Khatib and Alami has multiple departments: architecture and planning, infrastructure that covers also transportation, water, utilities, and geotechnical, digital services department, which we are from, the digital service department, and most of the presentation is going to cover the digital services aspect, energy, and PMO office, of course. Khatib and Alami has more than 2,500 employees within the kingdom. 37% of them are Saudis, of course. It has been working for more than 50 years here and has covered hundreds of projects. Within Khatib and Alami, you have the digital services department, or the digital services team has more than 300 experts, more than 35 years of experience, more than 500 completed projects, and of course, the digital Khatib and Alami is an Esri Platinum partner and has multiple partners on a number of services and a number of sectors as well. So, to dive directly into our topic today. The topic of BIM and GIS integration is a little bit old now. It's not groundbreaking. However, a few ideas and a few points that really need to be covered. The idea is that BIM and GIS do not compete. Okay, they are different parts of one whole, and the only way to see everything is to see all of the parts, which are actually how we can utilize BIM, in our case, within GIS environment. So, in order to get to that, the end goal is not to integrate BIM and GIS. The end goal is to serve your use cases and to serve your clients and to serve your business requirements. So in that aspect, we have a roadmap, or there is a journey, and that journey starts by a roadmap, by identifying your use cases, by identifying your business requirements, by understanding how to get to them, then designing your database so that it covers those requirements, and then modeling and creating your 2D and 3D models, and then building applications, integrating with IoT. So it's not a one-click button thing. It's a journey that gets you towards an integrated city model. Now, from the roadmap actually should cover multiple pillars, which are your business, your data, your applications, your technology, your human capital, which is the most important pillar, and of course, cybersecurity, which is very important within the kingdom. Of course, it's a phased implementation process. It should be scalable. It should grow organically within your organization. It includes defining your technologies. It also includes, as I said, identifying your use cases that you are going to implement. And of course, it includes assessing the current situation and what needs to be added. Those use cases always cover all aspects of a project lifecycle. So they are not only on operations or in the design phase. They start from the design phase and they grow with you while your project grows from design to construction to handover to operation, of course. And once you identify all of these use cases, you can start building your applications. Now, when we talk about seeing a BIM model in GIS or integrating BIM and GIS, most of us think that I need to integrate my whole BIM model into my GIS database, which is not correct. Because based on your use cases, based on your use case that you already identified, you can then start to pick things from your BIM model that you need. So you can handle the load of your, the size of the models, the size of the storage in your enterprise architecture, and a lot of things. So For example, I might need to see the full model as a 3D visualization, or I just need my floor plans for an indoor navigation, or I need my MEP equipment for operation phase, or I need them for security purposes to integrate with CCTV, or I might need the asset information for operations, copy information, and others, or I need them for sales and leasing. So I just need to see the units, and then I don't need the MEP, for example. And I might need them all. But identifying your use case will help you to identify the data that you need to extract from each of these, from each of the elements within the model. And then once you have your use cases can be varied. You can have a 3D GIS model, you can have a 2D that's integrated with BIM, you can have an Unreal Engine, you can have a 3D model that's connected to IoT devices, you can have a digital twin model that's LOD1, but it actually covers the utility network and it integrates with different SCADA or different data that gets you your energy consumption, which you can visualize, or it can also include a mesh model of a point cloud from a drone survey or others. So as we mentioned, based on the use case, you develop your application, you develop your roadmap, you develop your system. And this can look something like this. So it can be a BIM model that's converted to GIS, that is in a 3D scene layer that you can actually integrate into a dashboard. And in that dashboard, you can, once you zoom in, you zoom out, you click on something, you can see different data that is going in your KPIs and in your systems. This is for a health and safety inspection on a power plant, but it can be different things. And those health and safety inspections are related to images, are related to data, are related to the KPIs that are updated. So once we identify the use cases, and if we go back to our journey, we mentioned identify the use cases, build the roadmap, and then draft your standards, your protocols, your best practices. So we always need a common language throughout our projects, and we need a common language between BIM and GIS experts. Because in BIM we say, for example, EIR, and we say AIR, but in GIS we say a data model, and a database design, and a schema, or a template, so we need to kind of map these different namings and have and have a mapping between them, so that the documents, when people say EIR, the GIS experts understand, and when the GIS expert says a data model or a schema, the BIM team understands. And this starts from the project initiation all the way to the facility handover, and because at each point of a project, a model or a data changes hands as well. So, for example, from the concept designer or the designer to the contractor, from the contractor to the facility to the operation team, all of these can be different companies, and different companies would have different understandings of the data. So if we don't have a common language for them to go through, they will not be able you will have data loss, you will have to have a lot of rework and a lot of things to update again. Now, already in ArcGIS Pro, and I think some of you have already tested it, there is a mapping between how we read Revit models and how we read how it is converted into a GIS. So a normal Revit database would have, for example, cable trays, it has floors, it has walls, roofs, windows, and other things, and these are mapped into data sets: architecture, structure, electrical, mechanical, and floor plan. And these data sets have different already features inside of them, which you can actually utilize. And then the discipline in a Revit model or a BIM model is actually equal to a feature data set. A category is equal to a feature class. So walls, for example, are categories. In Revit, they are feature classes. Families are attributes, and types are also attributes. So different families of all the walls would be converted into one feature class, though you would have like 100 millimeter wall, 150 wall, structural wall, or block wall. All of them would be converted into one feature class combined. However, in that feature class, you would have a family and a family description as attributes where you can actually distinguish these things together. So when you design your database, and we're talking about databases and how to work with the databases. When you design your database, you have to think of a few things. So the database should cover all of your use cases. And we come back to the use cases because the business is the most important part. So it should cover all of your use cases. Do I need to convert everything, as we mentioned? So I can think of only converting or adding to the database the elements that I actually need. Can I use a scene layer package to make things faster when they are published? Does it have to be 3D? So that's a very important question. Do I have to have everything in 3D? Does it have to be a multi-patch? Can I see it as a point feature class? Can I see my mechanical equipment as a point feature class? Can I have it like that? Can we merge different instances? Can I merge all of the walls and the floors into one element? Do I need to have a separate elements for the walls and floors? Do I have to have an LOD 300 or can I have an LOD 1, which is a simple visualization, and all of that supports how to deal with these large-scale models into your platform. And then we need to have a coding structure so that it goes to the operation team. A coding structure, it's for the asset management system, so that will allow you to actually map with the operation softwares later on, and then a unified naming convention so that if different people are coming in, they can know what is this and what is used for and how to deal with these things. On the other side, when you're building your BIM model, there are a few things that actually you need to tell the BIM managers what to actually focus on for you. So all of the required geometry should be modeled. For example, in most of the GIS, we actually consider the exterior shell of a model. So we need to make sure that all exterior elements have, for example, an attribute, a function called there's a function attribute within parameter within Revit that should be added to exterior. Elements should be modeled correctly. For example, parking slots should not be modeled into more than one element. If you want to integrate later on with the parking management system,
needs to grab one of those
you need to have your metadata. You need to have all of the properties added, including the asset code that we talked about in our database. The model should have, of course, that's the basic thing. A model should have accurate and correct coordinates and georeferenced. Do I need my model for sales and leasing, or do I need the spaces for other activities? They should be there, and all rooms should have their own space. And then it should have a correct floor segmentation so that if I filter to a specific floor in my GIS, I can see that. And also, I should not have in my BIM model a work set that says to be deleted. And then the model is shared with the GIS and it is converted and you can see those elements. Or something like temporary or work in progress. So all of these should be deleted before they are shared with the GIS team. Now, so we talked about the database, and I want to jump to the AI part of the database, because these are interlinked together. Once you have your database designed well, you can actually build AI applications to cover that database. So, and a GeoAI application can help you engage with your data, can help you visualize better your results through prompts and through natural language prompts or commands. It can help you G-enable your insights and chat with your map, of course, to eventually change the way we're dealing with our data. An example of this, or a high-level example of this, is an application that we actually built within Khatib & Alami, and we developed this into a widget that you can add into your different applications, 2D or 3D. You can actually query the database. So you have your GIS database. You can query it and ask, how many parcels do I have? What is my biggest parcel? How many parcels that are within a specific road? How many schools do I have? How many valves do I have? What is their size? Give me a pie chart, or create a pie chart that, for example, for these valves or parcels or others, show me a bar chart of them. Show me, for example, in this case, a pie chart for the schools in a district. So it creates this pie chart for you. It can actually also integrate with the map. So it can ask it to go to a specific location. You can ask it to pull up data from your database and add it into a map. You can ask it to remove it, print, use the different features that you normally create. And this basically revolutionizes how you're dealing with your UI when you're building your applications as well. So in addition to that, so it doesn't have to be a GeoGPT model. It can be a GeoAI model. And I just have an idea here of a few applications that we also developed for different clients to detect either cracks in the road or detect street signs and related to transportation. But we actually also built the same and implemented in Oman to use satellite imagery to detect permit violations and then send people to check on these permit violations. So this is an example, but basically you can use it on multiple fronts. You can use it as a GPT to change the way you're seeing your model or working with your applications, or you can use it separately as a tool. And I think yesterday they covered part of this as well within their new technology. We have been already working on this for a while now. So when we design the database, when we think of the application, we identify the use cases which are on top. We start thinking of how to visualize them, and we have our data sources. These will go into the standards we talked about. Those are validated, they are mapped, the model is created, it is visualized based on how we need it to visualize to cover the use cases on top. And eventually the idea is to reach a point where you have a platform of the platform. This platform actually covers different verticals within your organization or environment. So we talked about the digital twin. Graziella in a bit will talk about the urban aspect of this. Walid will talk about the utilities aspect of it. Mohandas Turki will talk about the planning aspect of it. So you'll see within the session how we are actually building this, the different blocks of this idea. And then finally, just to show you how when you have a good database, when you have your 3D data correct, you can actually combine BIM models with GIS data, with your data coming from P6 or for time and cost to actually interact with your model, build 4D applications, for example, build applications that have a 5D aspect of them as well, or even have check the 3D model within your own application. So you can see how we can actually zoom into just one area or one model. You can add your images, your 360 images, your site images. You can add your site documentation, and you can add even your CCTV data if you have any of them. So this is from my side. I'll give it to Graziella to continue.
Is it working? What we'll be doing now is an use case where we to tools and create beneficial tools.
Hi.
So as an introduction to the urban planning use cases that I will discuss now, first of all, informed decision making requires understanding where things are and how they perform. So that can be handled by GIS tools. It can help us through accessibility and network analysis, population coverage assessment, and spatial interpretation of qualitative data. I will be discussing two use cases that we have applied during our projects. One of them is the application of 15-minute concept, which is the proximity and accessibility. And the second use case is the sentimental analysis, which is that talks about the experiences of these services that were provided by the first use case. So what are the two questions that I'm trying to answer here with these two use cases? First of all, can people reach daily services? Are they, what is the situation of the proximity and accessibility, the walking time and to reach the daily services within the city? The second question is, how are these services experienced? Public perceptions and satisfaction of the people using these services. So GIS was able to help us explore these two use cases spatially. The first use case that I will be discussing is measuring access. In this case, we are talking about the 15-minute city and its challenges. What is the 15-minute city concept? The 15-minute city concept discusses, it shows us how can we access our daily services within the city in an amount of time, whether it is from 5, 10, 15, 20, or whatever time it fits the best, the situation that we are, the city situation. The second thing is it focuses on proximity for everyday services to help answer the challenges of this concept. We GIS, sorry. It measures, first of all, actual time traveled by distance, walking-based service reached, population coverage, and uneven access within the same area. The challenges are, how can we see the city, that all the parcels within the city are equally serviced at the same type by the same services and evenly distributed within the city? And are people living within the city really able to reach these services to cover all the population? What is the methodology that we use to implement this concept? First of all, we started by defining what are the data that we need to achieve this methodology, starting by population distribution, the parcels, pedestrian street network, and the point of interest, which is the service, all services, whether are public or private, within the city and their distribution. The second phase is the city-specific analytical scope, which is tailored to the city itself, each city itself. So it will show us residential population patterns, local relevant daily services. So to each city and every type of people living within each city, they have their own needs. So it's tailored to their needs. City-wide coverage adapted to urban context. The third level is the time travel parameter. Here we started to look into what time frames are best to describe this, to fit the needs of the people within the city. So based on the walking accessibility, we started to set the time threshold that we can benefit from, and this is based on, of course, on the needs of each city. And the third thing is the scenario-based analysis, of course, which is where it fits best, again, based on each city. So what are the spatial analysis that we have able to reach? It's parcel level accessibility catchment. We're able to catch for each parcel, define the catchment of this, of the time frame specifically based on the network that is available. And linking not only the parcels, but linking them to the population distribution that are within the city. Here, where the outputs were two, mainly that we were able to reach. First of all, the dashboard that is supporting decision making, which is the very technical dashboard. The second one is for the public, which is an application that can help people understand how can they reach their services, what is actually surrounding them. The main outputs were, first of all, on two levels. First of all, the parcel level, and the second one is the population level. It helped us, if we can define more, where are the gaps within the city, and how can a decision maker make the right intervention of the specific POI needed to cover all city equally and to cover it in full. And not only that, we also we measured also by population, so we can make sure that that decision maker can say that 100% of the population is able to reach their daily services. We also tried to see it by each service. We covered in this area, we see based on the categorization that we adapted for this specific use case, each main category contains several subcategories. For example, for daily services, we have, for example, grocery stores. How many people are able to reach these stores, and how many even land parcels are covered by these services? This tool is able to help decision maker, first of all, reveal all the gaps within the city, support that any intervention that is done on the city is supported by evidence-based data, and then the next step will be targeted intervention on the city. So from this point, which is the quantitative aspect of this analysis, we started to see that it is not enough to see that the city is only covered by services. We need to see if actually these services are at the quality that we need, that people will not be able, like if I want to visit this grocery stores, that this is from a good quality, then now I don't need to visit maybe another one. I want to see like all the city at the same level of best quality to ensure, of course, the quality of life within the city. So the second use case is measuring experience, and this we did the sentimental analysis, which is we took all the data online of reviews from social media, from Google Maps, and we tried to analyze it internally to capture the public feedback, to structure qualitative data into measurable insights, and to understand how services are experienced over time. So what is the methodology applied? First of all, we started to identify what are the POIs that we need, or point of interest that we need that are available within the city. The second phase was structuring these feedbacks that we gathered of the data that we collected, not only from POIs, but also from the reviews that we have. And we classified them by multiple aspects to see how, what is exactly people are saying about these services. And to have an accurate representation of the community insights, and to finally, within using GIS tools, we're able to translate these data into spatial mapped and geographically mapped information. Not only that, but also with using charts to help also the decision maker to best read the city. So some of the charts that we are able to collect based on these data, to generate based on these data, is user opinion based on time periods, user opinion based on type of service. So what for each services we can category of services, how are they people satisfied or not? Assessing various the total situation from positive to very negative, and by aspect from very positive to very negative. In total, in conclusion, GIS helped us spatially to understand the city. We were able to not only see the city as a point of as only physical the physical aspect, but also to hear and to translate what people are saying into spatial data, and spatial insight supports more informed decision. It is the base for any decision making within the city. So now we are not understanding cities requiring not only where services are, but also how are they perceived by the people.
Can you all hear me? Thumbs up? Yeah? Okay, great. So Mahideen, Graziella, thank you so much. I'm not going to take up a lot of your time. I'm just here to talk about the challenges for the utilities and how the GIS can help with those challenges. So the utility challenges are specific to the MENA region, that what you're seeing here. The first and the most important is this duality of the transmission and distribution losses coupled with the need for water. So you have water scarcity here, and there is this energy-water nexus that's happening where you need to consume more power to produce more water, which will cause more stress and strain on the grid itself. Then you have the issue of the extreme demand growth that you're seeing, and that is also coupled with hard loads and hard demands that you can't escape. Chief among them is, of course, the cooling in our region, and the water desalination, and the urban growth, and the rapid changing environments around us. All of that is causing the demand to spike. In fact, it almost tripled between 2000 and 2024, and it's still expected to grow up to 50% by 2035. You have also the issue of decarbonization and renewables entering into the grid, and that's causing additional stress because, you know, substations and feeders might not be able to absorb all that load from the DERs, and the capacity management and the management of the grid becomes even harder when you don't have full visibility around how the grid is operating. We also have the challenge of climate change, and that's we're seeing this day by day. You know, you have heat islands, you have flash flooding that's happening, you have all of that kind of issues. Add to that some geopolitical risks that are happening, so we need to make sure that this grid is secure and is able to provide us secure energy so that we can have reliable services. The customer experience is also changing. Customers today need to understand how their data is being used. They need to understand how their consumption is affecting the billing. They need to change maybe their behaviors, and all of that is additional stress on the utility that they need to take on board. Not to mention the digital readiness of the utilities. So while you're seeing that there is maybe around $170 billion that's going to be spent on IT in the MENA region in the coming few years, the utilities themselves are still lagging in adopting all of that investment. So how can the GIS help, and what do utilities really need to take advantage of what's going on? First and foremost, we have to have a system-wide coordination that happens between not just one aspect of the grid, but all the different utility networks working together, and all the different parts of the grid, and how we can go from planning all the way to operations and maintenance. Then you have to have this common view, common picture, which Mahideen alluded to earlier in his session, and that's all about having this holistic picture of managing the grid altogether. The data-driven business intelligence, data is becoming, you know, a critical aspect of the work and of the utilities. So how do we make use of the data that we have, the historical trends that we're seeing, the predictions for the future, weather and IoT data, and advanced metering infrastructure data that's coming into the grid? How do we balance all of this to create or ensure that our assets are performing optimally all the time? And of course, integrating all of that information together through a common platform and through a common environment. So once the utilities are able to do all of this, they can actually start approaching modern grid management in a better way. And why do we say that the GIS helps? Well, today, with the ArcGIS Pro and the utility network capabilities, we're starting to move into the service-oriented architecture that helps utilities in a couple of aspects that I'm going to give you examples of today. Chief among them is the modeling. So that starts, of course, on the basis of where we grow. So we have to start with the modeling phase. Then we're going to see examples around interoperability and how those different systems are coordinating and communicating and collaborating together. We'll talk about enterprise access and sharing this single source of truth with field crews, with people that are on the web application, with executives that just want a higher view picture, and of course the quality of the data and how we can improve that through more digital processes. So the first example around modeling, as we all know, and as you're all familiar now, the utility network gives you the capability to model multiple utility domains, as you can see on these examples. So you have distribution utilities, transmission, water, district cooling, all of that is possible. And not only just the model itself, but the granularity of the assets, the connectivity of the assets, and how those networks are behaving. Okay? When it comes to interoperability, here we're talking about how the GIS becomes interconnected with other systems, like your SCADA and ADMS systems, advanced distribution management systems, like your enterprise asset and work management systems, and your customer billing and information systems. Together, that creates an opportunity for the utilities to better understand how their assets are performing, whether they are at risk of failure or not, and making sure that their operations are always in line with what's happening around them. So that full kind of operational picture. Of course, integrating with things like SAP or Maximo or Oracle Primavera or all those different systems becomes more possible. And we also have this kind of exporter to a common information model from the utility network, which enables you to open the GIS and those other systems. When we talk about enterprise access, we mean that we're sharing and democratizing that data from the GIS, that single source of truth, with the other applications out there. So we're talking about targeted portals for the customer to go and probably do their payments online. We're talking about recovery of the revenue through mobile payments and the collection of the metering information. We're talking about monitoring dashboards, reporting outages, all of these kind of different applications that become possible once we have GIS at the center and opening it up to the different systems. So we can create this common operating picture, as you're seeing in this example. This is a real-life example of the GIS being the source and having a common operation picture for emergency and anticipating kind of weather events before they're happening and their impact on the network. Okay, and you can tie in the CCTV cameras from your crews. You can make sure that people are going where they need to go in real time and not to the wrong place. Last but not least, I'll talk about the data quality, and that brings me to the fact that you have to have those data control points on various inputs into your GIS. Starting with the design. So your design has to be digital, whether you're using third-party design tools on top of the utility network, like ArcFM Designer 11, or whether you're doing, CAD designs and just having a portal for your contractors to submit their designs and converting them into the GIS. Okay, so all of that starts with having this complete system. So thank you so much. I'm going to hand it over to our client from the Strategic Office for the Baha, the Region Development, Engineer Turki, please.
And we're bringing all that data to the GIS community directly in the way that works first and foremost for you in a product that you receive and the way that you expect to receive it. So the HereGIS data suite's ready to go, right out of the box. You don't need to do anything to the data. You just pretty much, you open up the ArcGIS Pro project. We have the file geodatabase. You're ready to go. Includes a robust network data set to enable location analysis utilizing ArcGIS Network Analyst. This will help you do your route solves, your vehicle route problem solving, service area analysis. It includes accurate locator files. These locator files are built on point addresses, micro point addresses, which is your unit and suite level addressing. Also built on high quality, high integrity places data with over 400 categories. All this data is fresh, curated, trusted. Quarterly updates, no matter where you're at in the world. Quarterly updates everywhere, so you can always be sure that you're getting the highest quality data that you can, and you can always trust the data that you're working with. All this comes in custom areas of interest, so with the HeroGIS data suite, you can buy any area of interest that you're interested in. You don't have to conform to any certain administrative region. Whether or not your service area, so for example, if your utility service area might not necessarily conform to any particular administrative region. You can have the HeroGIS data suite just bought for the area that you serve. So you're not dealing with extra data, a lot easier to work with. You're not trying to deal with anything that you don't need to. So the HeroGIS data suite is a comprehensive package that empowers your GIS operations. It includes everything that you need to go right out of the box. First off, it has the file geodatabase with the Hero data. This is also available as a geo package. It includes over 70 feature classes that have the data transformed in a way that's easily understood and makes sense to the GIS professional. We include that network data set inside the file geodatabase. It has a transportation network ready to go, including historical traffic. We have a vector tile base maps included as well. These are base maps that are fast, professional, easily customizable, and really serve as a great backdrop for your GIS operations. We include locator files as well. Like I mentioned earlier, these locator files are built on point addresses, micro point addresses, places data. Very reliable, quick, easy to use. And all this comes ready to go with an ArcGIS Pro project file. Now, this might sound like a rather minor detail, but having an ArcGIS Pro project file really actually adds a lot of value to the product in the way that it has all of your data symbolized, ready to go. As GIS professionals, we know that symbolizing data, this is really a basic sort of function of our profession, right? Anybody can symbolize layers, configure them, but when you have over 70 different layers, making that all work together in a way that's efficient, professional looking, and that makes sense, really takes a lot of time. So having this as a good starting point really serves as a lot of value. You can use it as is, or you can customize it and really make it your own. So the HeroGIS data suite comes in a few different components, right? There's 3 different components. The first component of it is really this foundational data set. This is data that represents the world around you, really base data, right? Includes building outlines, land use, and more. We have detailed and built environment information such as building outlines, bridges, ramps, footpaths. Land and administrative context covers land use and administrative boundaries. Complete transportation network features such as the roads, tollways, railways, and cartographic data like water bodies and surrounding terrain context. As I mentioned earlier, we have the network data set that's included. This is a really highly detailed network data set that allows you to plan efficient real-world routes and analyze service areas using this detailed, robust network data set that reflects actual road conditions and historical traffic patterns. So, utilizing a network data set, this is basic functionality that comes with ArcGIS Network Analyst. The big difference here, though, is that you have Hero data that's backing it. So you know that you can trust the output of the network data set. You know that you can have a lot of faith in your analysis. We mentioned earlier, too, we have these locator files, right? These are really highly detailed locator files with micro-point addresses, places data, administrative boundaries, street address ranges, and more. So the HeroGIS data suite comes in 3 different components. There's 3 components put together, comprise or make up what we call the standard HeroGIS data suite. The standard HeroGIS data suite is what we expect customers would need most of the time. The first component is that basic foundational data set that I mentioned earlier. This is data that really describes the world around you, base data. It includes the file geodatabase and those vector tile packages that I mentioned earlier. We also have the road infrastructure, rules, regulations, and traffic patterns. This is advanced data on roadways and traffic, including a network data set. This is traffic patterns, speed, safety cameras, E-levels, signs, lanes, traffic lights, black spots, railway crossings, alerts, and more. And this comes with a file geodatabase and a network data set. And then lastly, we have the addresses and places, as those are micro point addresses, highly attributed places, including a locator file. And I will also add that not only do we have these point addresses and micro point addresses in the locator file, but we also have the point address and micro point address data itself, so you can work with the data directly rather than exclusively through the locator file, which you might find on other offerings. We also have cellular signals. Cellular signals is an add-on data set that has cellular signal and strength that's aggregated by both carrier and signal type. We also have it aggregated to roadways. So if you have operations that depend on, for example, let's say a 4G coverage for a certain provider, you know where you can expect to have coverage for those operations, and you can plan accurately around that. So what's this all mean for you at the end of the day? This has a huge business impact, right? It unlocks efficiency. By having all this data ready to go, you save significant amounts of time. If anybody's ever tried to compile this sort of data on your own, you know that's quite a task, especially when you have larger areas. So having to pull together all these different data sources, vet them, make sure that they're high quality, harmonize the data, takes a huge amount of time. So you really save a lot of time by having this all ready to go. Expanded opportunities. So by having trusted data, by having this comprehensive suite of trusted data, you can really expand your horizons as a GIS professional. By having this trusted data, you know that this is data that you can trust, right? You can feel comfortable to take more decisions, take more chances, and really stand behind your work and really demonstrate the value that you bring to your organization as a GIS professional. All right, so how it's sold. We have worldwide coverage with exceptions of areas like China, South Korea, and Russia as well. If anybody's interested in more detailed coverage information, you can go ahead and scan this QR code. This will open up an Experience Builder application. And yeah, you can learn more about the coverage. All right, so I'm going to go ahead and walk through a really quick demo of the HereGIS data suite since we've talked about it a bit. And yeah, let's see what it looks like in practice. I'll have to get over there. Thank you. All right, everyone. So as I mentioned, the HereGIS data suite comes ready to go out of the box. What we're looking at here is what it looks like right away, right? So you just go ahead and you open up your ArcGIS Pro project. It's connected to all your data sources, your file geodatabase, your locator file, your vector tile packages. What we're looking at here is the data for Riyadh. We can go ahead and zoom in here and we see we have our building footprints, we have our street addresses. Oops, I zoomed a little far out there. On the left-hand side here, you can see that we have a lot of different layers available. We have truck restrictions, traffic lights, signals, cameras. We have the network data set, places data, very comprehensive places data. You can see all the categories that are available here on the left-hand side. If we come into the catalog, we can go in here and we can see the different data sets that come with the HereGIS data suite. Over 70 different data sets in here. And we have our locator file and our vector tile packages and map. So I'm going to go ahead and switch back over to the slide deck. All right, thanks everyone. So if anybody wants any more information about the HereGIS data suite, go ahead and scan this QR code. If anybody has any questions, feel free to reach out. I'm definitely really interested in seeing what you guys think and where we can go with this. And with that, I'll go ahead and hand it over to Bruce from IRL.
Thanks, man. Hi everybody, can you hear me right here? Perfect. Okay, so yeah, I'm Bruce from IRL. We are a consultancy that specializes in putting data about people on top of the wonderful foundational data sets that our partners at Here Technologies provide, as well as inside Esri environments. Now we bring together multiple, so more than 65 diverse data sets about population and people and human movement to help make sense of the world, not only about, well, where do people live and what do those populations look like? We've got that data, of course. But what we layer into that is then, what do those populations like to spend their money on? How much money do they have? And then most importantly, where do they go? So how do those populations, distributions change by time of day, by day of week, and right down into the lower level? And we're getting billions and billions and trillions of events around human interactions in the real world. And we bring that into our cloud environment, and we're using new technologies like machine learning and AI technologies to bring all of those massive signals down into data sets that professionals and GIS professionals, data sets the size that those professionals are used to using, to help inform decisions. And specifically, the consulting component and the strategic component of our business sits on top of that to help professionals like yourselves actually make the decisions with confidence that solves the problems that you are faced with today. So our foundational sets that are sitting on top of the built environment and the traffic data that here technologies are, our partners give to us as well, is we understand residential demographics, which I'm sure that I don't need to explain. We understand consumption expenditure, and then we bring in the here technologies data sets like POI. So what are the places? What does the built environment look like? And then how are vehicles moving across and between those built environments? Then what we bring in, and this is really the secret sauce, is we bring in billions and billions of events of mobile phones moving across the landscape as well. It's called, so we call it mobility data, which is slightly different to what I think most of the industry understands mobility data as. And so this is human mobility data at scale. Now we've been working across the region for about 5 years now, and there is robust sample across the whole of the GCC for us to be able to provide insights and help inform decisions across the region. Now I'll go into some detail with some examples of work that we've actually been doing in the region, and so let's dive into it. I think most people like to try and understand these mobile phone location histories and how we get it and how it works. So we get our mobile phone location histories. We don't get it from the telco providers. We get it from the app providers themselves. So we've got an integration with hundreds of thousands of apps that provides us with anonymized mobile phone location histories from opted-in panelists only. And that data all sits within a secure cloud environment, and the whole process is designed to be both PDPL as well as GDPR and any other local laws that apply compliant. These massive samples of people, okay, good, this is playing. So these massive samples of people moving across the landscape allow us to get insights into, so what we've plotted here is where do devices that work in CAFT, in the CAFT area, where do they come from? So this is advanced origin destination capabilities now. And we can define the areas of interest anywhere in the world that we want to understand where do the visitors come from. Because the machine in the background is learning over time the suburb that the device lives in. So we can understand what the relationships across the city are like. Now, if you're interested in traffic and mobility across the city that you're operating in, this is a massive unlock, right? Because it's not just about congestion. From this, you can infer intent. And I think that's a major breakthrough in our understanding of the way that people use cities. Now, obviously, this is sitting in root data, and it's a massive data set in the background. You can imagine we've got this for every place in the GCC practically. So it's not useful for everybody sitting in this room in this form. And what we do as a business is we apply some really smart technology and work to make it useful for those of you sitting on the front end. So the demos that I'm going to show you today, and what do we do that's useful with this data, are quantifying seasonal and long-term population flows. So in and out of cities, in and out of parts of the cities, across the country that you're operating in or between countries. Profiling visitation at a sub-city level. So understand during a Tuesday afternoon which parts of my city or my town are more busy than others. And then deep diving into origin destination flows. There's some really good stuff that we're going to show you in a minute. And then we're going to speak about international visitation profiling. Because the mobility sample is global in the natural way that it occurs, so we can start to understand for tourism applications, where are visitors coming from and how is that trending, and then ultimately understanding and measuring. Excuse me. What have I done here? Local behavior in response to infrastructure changes. We're just wrapping up now on a study of how did Riyadh residents, the way that they live, change after the metro opened. We've been doing some work with Capstock. We were hoping to present some of it today, but unfortunately it's still under embargo. So hopefully next year we'll be able to show you some of those results. It is a really beautiful thing to be a part of. All right. We also bring all of this data together in tools that are ready to go. And so this tool we call the Urban Trend Scanner. And what we've done is we've broken the whole of the country, the whole of the world down into these Uber H3 hexagons. And then we've looked at the way that devices visit each of them across 2 different time periods. So this example here is from Q2 versus Q3 2025. So April to June and July to September, we compare the visitation at each cell's level versus the test period versus the secondary period. And from this, we're able to paint a picture of how is visitation changing. Now, we've scaled this across 2 variables. The one is visitation increasing or decreasing? And then is dwell time increasing or decreasing? So the dark purples both of them are increasing, and the pinks are visitation is increasing, but dwell time is not increasing. And then that light blue is dwell time is increasing, but visitation isn't necessarily increasing. And then the lighter stuff is it's flat or it's going down across both of those verticals. Okay, so what you can see is that there are these 2 islands of brightness across Riyadh. There's a couple of islands of brightness, but we're just going to go into 2 of them for this demo. And you can see here we're at King Salman Park here, and what we can see is that there's been a bunch of increase in visitation, not only from a footfall point of view, but also from a dwell time point of view. But then if we toggle on our weighting, so it has to be a lot of feet. For it to be significant. Well, which of these cells are significant? Well, we can see the bits of the park that aren't developed are not significant. But here at the visitor center and the museum, you can see that there is footfall going on. So why is this an advancement? Well, because when you want to understand how people are using the city, you used to have to look at satellite imagery and maybe have a guess and see whether somebody's posted something about it online about being open. From here, we can actually see visitation. Now, this is a new residential area in the northeast fringe of the city. And again, when we turn on the weighting for footfall, we can see that only the southern part of that new housing complex has actually got meaningful visitation taking place there. And the northern part, even though some of it's built, and the satellite data is going to tell you that there's roofs there, they're not full of people. Okay. Now, I've zoomed into just the CAFT area. We don't actually have to only geofence these polygons. This is a mall that we've geofenced in the CAFT area. And we now profile it from a mobility point of view. So it's Red Park Mall. We can see that people visit that mall as well as other malls in the area. We see that the dwell time is just over 101 minutes, and that people tend to visit there about 5 times a month. And what's really interesting now is when we define the catchment area, there's a primary and a secondary catchment area, we can see that this mall draws from a much larger area than its compatriots do. And that's obviously because CAFT is a work destination. Then we look at time of day and day of week visitation. And what was really interesting about here is that Friday is the second busiest day, even though the opening hours are half of what they are on the other days. So if you ask somebody in the mall which is the busiest day, they're going to tell you Friday, because that's when it's most crowded. But actually, from a total footfall point of view, Friday is actually the second most important day. Now, this tool doesn't just enable hyper-local trend analysis. You can also look at broad trends. So when we look at areas of stability, you can see that during those hotter summer months in Q3, you can see that the core of Riyadh, there wasn't a lot of footfall growth in the interior there. And in fact, there was most of the footfall growth happened at the city fringe. But where else did it happen? Well, we know that people leave Riyadh during those hotter summer months. And you can see Abha, we can see a bunch of growth happening there. And Al-Baha. And excuse the pronunciation, everybody. So you can see that that's actually where people were going, and that's where you could see increased footfall. And if you are thinking about providing services, those are the areas that you should be looking at. Now, it's not just leisure study that gets leisure travel that gets picked up here. You can also zoom in on Duba, for example, which is the gateway to the Neom precinct, and you can see there the increase in footfall there is probably most tied to the increase in commercial activities that are taking place as that transit gateway into the Neom area. All right, so I'm actually going to cut this demo short because I know that we're in a bit of time, but I think it's important to understand that we're taking all this complex data. We have the ability to break the whole country down into its parts, and then understand at a hyper-local level what's happening from visitation, understand where new changes in footfall are taking place, and then at a larger scale, understand how visitation is changing too. Here's an example from understanding, well, what has happened to visitation at Bahrain from international visitors. So we can see this trended over time, and we can see international visitors spiking during the New Year's period. And what was really interesting is understanding that the same pattern didn't necessarily reflect when you looked at devices that were registered in Saudi and live in Saudi. The visitation actually to Bahrain during the period that we're looking at had been dropping off, and we weren't seeing the same spikes. So if you're responsible for tourism in Bahrain, there's some really interesting signals happening there that you can obviously go and address. We don't only have to do that at like a country or a city level. We can also understand for specific destinations or attractions, where are the countries of origins for your visitors coming from, or what does your international attractiveness look like, and importantly, how is that trending over time? All right. Next up, we don't have to guess at the catchment areas for attractions anymore or destinations. And this is a really important unlock when it comes to city planning, or if you are responsible for a network of services or attractions. So whether it's malls or retail outlets, or tourist attractions, or whether it is healthcare, or any other services where there are outlets that are customer facing, is that when you understand what your catchment area is, you can track that over time and you can allocate resources better to it. So in this example, what we've got is we've got a destination here in Bahrain, and a competing destination opened up nearby to it. And so that's what their catchment area looked like prior to the competitor opening up. And then we can see what kind of impact it had and where that impact was felt. Okay, all right. I'm going to move faster here. So we can see what actually happened to that catchment area, and we can observe the changes over time. Then understanding how new infrastructure affects the way that people visit places. We can see here a new mall came online. Everybody went to go and see it, and then a new norm of the way that people visit malls in Bahrain was formed quite quickly after that. I think this is arguably one of the most important slides for the people in this room. What we've done here is we've broken up the whole of Saudi into an origin destination matrix. And so what the machine has done is it's learned the devices that live in each one of these polygons. You select the polygon, and it doesn't matter where it is in the country, it'll show you where the residents of that polygon like to visit. So now when the machine plays those all off against each other, you can start to get an understanding of, by suburb across your city or your town, you can understand what the travel extent are of those residents and you can go and identify very rapidly where the underserved residents are for whatever the service it is that you're trying to provide. All right, we can also zoom out to the city level. This is the last slide, so we can wrap up quite quickly now. And understand, so we did a travel study of understanding how do Abu Dhabi residents visit Dubai. So the first thing that we looked at is what proportion of Abu Dhabi residents can we see visiting Dubai on any particular day. And it's really interesting to see that trend coming down during the course of 2024. Next up, we looked at what do the trips look like. Are they day trips? So that's the white over there. Or are they overnight trips? Or are they slightly longer trips? Is it a bit of a weekend trip? We can filter that down. So we wanted to understand for affluent residents of Abu Dhabi, is their visitation different? Is their visitation patterns to Dubai different? And the short answer is yes, they are. What we can see here are day trips are significantly less prevalent for affluent. So what we did was we just filtered them by people who had visited a high-end mall to get that affluent stamp against it. And then we looked at how are those devices visiting Dubai, and you can see it's a very different story. I wish we had more time to dive into it. And then ultimately understanding those behaviors by suburb of origin as well, which is a huge unlock too. Okay, so thanks very much, guys. It's a bit of a whirlwind tour. If you'd like any more info, scan the QR code, and we'll be happy to do a demo for you. I think in summary, the big unlock here is that there is fantastic data about the built environment and here technology's got fantastic data sets about the built environment and the way that vehicles move through that. Where there is a beautiful synergy is where we bring in the mobility data and we lay that on top together so that you can understand what the intent is of the population that you're trying to serve, and then how the traffic flows, and then how else you can be solving the mobility problems that come from intent of residents here to visit their traffic sitting in this environment, and then how you solve around that traffic too. Cool, thanks very much.
Assalamu alaikum, everyone. Can you hear me? Okay. Assalamu alaikum and good morning. And my name is Mohammed Brewish, the Managing Director of TrafQuest. And the focus of our presentation here today is going to be Clear Guide, which is a real-time contextual geospatial mobility intelligence. It is a platform that converts large data sets, traffic, raw data, basically road traffic data into actionable operational intelligence for transportation agencies and traffic agencies worldwide. Okay, so the presentation is going to be short because the intention was to focus on a real demo, a real life demo of the platform. But the presentation will focus on introducing what ClearGuide is, basically who are the intended users, and what are the expected benefits from the platform, and then the demo and next steps. So this is a very short video that gives you an understanding of what ClearGuide is. So we would play it and without a sound, but the sound is just music, so it doesn't matter. So في انترنت هون؟ It's a video. Later, all right. Okay, so what is ClearGuide? It is basically a platform, an advanced traffic data analytics platform that converts large quantity of traffic data, of road traffic data into actionable insights. It covers the entire network, all the corridors. You can create your own routes in order to study them further, and it covers all the intersections, the signalized intersections of the city. It provides years of historical data. This is up to the client, of course. In the case of our implementation for ClearGuide in Dubai, they've requested 5 years of historic data, as well as real-time data. All right, so in a nutshell, it takes the raw data, it processes this raw data through engines and algorithms, and it provides contextual performance measures and decision-ready insights. It provides daily operations, insights for strategic planning and decision-making. The source of the data as well as the source of the base maps is coming from Here Maps, our partners Here Maps, and I think Dan has already covered a lot about the sources of the data and how reliable the data is and the coverage that Here Maps enjoys across the world. So we take the raw data, the probe data, the floating car data from Here Maps, as well as the base map from Here Maps, and we basically, the platform is built on top of that. So, why agencies need or use ClearGuide? It is basically completely transforming how traffic agencies and transport ministries operate when it comes to the traffic data. It is transitioning them from a traditional approach to a ClearGuide approach or a modern approach. So instead of fragmented project-based analysis for a specific corridor or a specific area in the city, you have basically continuous network-wide performance monitoring for the entire road network in a city or in a country. Instead of basically reactive decision-making, you can have a proactive decision making. You see where the bottlenecks are happening. You see how frequent the bottlenecks are happening. You see where the problems are. You see why they are happening. And then it becomes an engineering problem that you have to come up with a solution for it by either expanding the road or changing the signal timing or come up with a different mitigation measure that solves the issue. Instead of wasting time on extensive data collection measures, studies, setting up cameras, traffic counts, you have all of this basically available for you at all times. Everything is going to be basically provided to you automatically, and instead of having inconsistent metrics to measure how efficient this solution has been or how efficient this corridor before and after studies, instead of having these different metrics, you have a consistent platform that provides you with the same way of calculating things so you can compare apples with apples, basically. So there is a huge time saving, 100% of network coverage, and it is continuous monitoring at all times. So who are the intended users of ClearGuide? Mainly 4 different, we can think of them as departments within the Ministry of Transport or the the municipality or whoever is responsible for the traffic road network, basically. So the traffic department or the traffic engineering teams, they use it for route analysis, optimization, reliability metrics, automated monitoring, before and after studies, bottleneck detection, performance benchmarking. There is also the operations team, the team that are working in the transportation management centers, basically monitoring the real-time traffic conditions in the city. They use it for real-time incident detection, response evaluation, work zone monitoring, congestion alerts, events monitoring, emergency response time monitoring, and the same platform is available for everybody. So the business model of ClearGuide is providing the license for the entire entity. It's not per user or it's not per road network length. So, for example, in the case of RTA in Dubai, every single employee in RTA has access to ClearGuide. And that provides a lot of consistency because you're using the same platform by different teams. Other teams or other departments that are very much interested in the ClearGuide is the strategic planning department, deciding where the bottlenecks are happening, which road projects needs to be invested in, which road corridors needs to be upgraded, what kind of tunnels or whatever measures you can come up with. So the strategic planning department in deciding how to expand the road network or how to improve and upgrade the road network. And of course, the ITS, the Intelligent Transportation teams, because everything in ClearGuide is connected with APIs. So you can fetch the data and hook it up with another system that you have in place so that you can leverage the data that comes from ClearGuide. So the major advantages, you don't have to install any kind of hardware on the road network, zero hardware. You have basically trusted metrics that are working 24/7. You have diverse use cases. As I mentioned, there are 4 different departments plus 1 in RTA that are using ClearGuide consistently. From the operations team in the TMC to the planning team to the strategic department and ECQ for the emergency response teams. You have basically a very easy, a quick setup for any city. As long as this city is covered by HERE maps, then that city can have ClearGuide within less than 2 months. So again, no infrastructure cost, very quick deployment, full coverage, and proven reliability. These are just some of the cost saving and time saving that entities or ministries enjoy once they implement ClearGuide, because I cannot really overemphasize the amount of cost savings just by time. I might actually mention a story where last year RTA raised the SALIC tolling tariff in Dubai. So they wanted to basically understand what was the impact on Sheikh Zayed Road in terms of travel time index and average speed. This used to actually take weeks, if not months, of a study just to give them this answer. You have to basically collect data before the tariff, before the SALIC toll was increased. And then you will have to do the same thing after. And then you have to basically cleanse the data and then come up with an answer. This was done literally in 2 minutes in ClearGuide, just showing what was the average speed on Sheikh Zayed Road before the toll was raised and after. So this is where I wanted to shift to ClearGuide. You have. Okay. So this is where I wanted to shift to an actual demo. So if you allow me just 1 second to connect. Okay, so this is the landing page, and you can basically go, and this is what we are going to look at right now is a real time the traffic conditions in Dubai in real time. So these, so basically, if you zoom into the network, you can see the bottlenecks identification engine in the ClearGuide is working automatically. But sorry about this, the internet speed. But so basically, these blue lines are identifying in real time what the bottlenecks currently happening in Dubai. So this bottleneck basically is 2.7 kilometer. It has a 3.5 minute delay. So if you want to zoom in a little bit, all right. So sorry, there's no mouse. So these bottlenecks are automatically being formed. And if you want to study, for example, any kind of road link that you want to investigate further, so you click on the road link. Everything is adjustable in terms of metrics. The link that I clicked on is currently operating at 19.3% below the historical average. It is currently operating at 17 kilometers per hour. If you want to investigate further, you click on this, and it just basically shows you the.
Can we start the demo again, because we got Jack and Esri team here. We're very interested to see the demo from the beginning.
Okay.
Please.
But is it easy to connect a mouse here?
It's okay. Continue.
Okay, okay. All right. So basically, the blue line is the real-time data. The dashed line is the historical average, and the dashed area, the shaded area, is the historical range. You can basically, this is available for average speed, average travel time, congestion, minimum speed. You can have all types of metrics available in here. You can also compare two different dates if you want, for example, time of day. And it was basically shows you the maximum minimum, and the average. If you want to compare two different dates, you just select the dates, and you can go back all the way to 5 years of data. So if you want to compare, the first week of January 2026 with the first week of January 2025, for example, you can just do this, and the first week with the first week, and you can hit render, and it will just generate the comparison for that particular link between the 2 months or the 2 weeks in 2025 and 2026. You can also, everything is exportable as a graph, a table, CSV, JSON file, or an Excel sheet. And this is just for this A to B link, which is very short. So what if you want to basically create your own route? You know, you have a corridor in the city that you want to monitor in more thorough ways. So basically, you come here, you click, you right-click, and you start a route. Sorry, guys, the internet connection is very slow. Let me just go here. All right, so let's skip this. You can basically, another feature is to identify the bottlenecks of the city. The ones that are reoccurring on a daily basis or a monthly basis. So here I am asking them to identify the bottlenecks that are happening. That was the case for the December 2025 for the weekdays, and show me the top 10 bottlenecks in Dubai. There's no internet.
It's about construction management and a geospatial foundation. It's about how we bring technologies together, specifically technologies such as Trimble technologies and Autodesk, to the table with GIS to help projects being collaborated and delivered. Construction usually generates a massive amount of data from the field and from machines and from sensors from all over the site. But without geography, things cannot be connected and everything will be fragmented. So the idea here is today we talk about the ecosystem, that geospatial ecosystem that kind of brings all those technologies together, brings everyone into one collaborative environment on GIS to help with the side of construction management, managing design within the field, but also understanding the kind of link between the reality and the virtual world, the digital world that we all use in order to get our projects delivered. Just would really appreciate your feedback again. Please take a moment to complete the survey for this session. It's available on the event app on the presentation page. So, construction sites usually generate huge amount of data. That's across design, planning, logistics, safety, operations. But this information is also very fragmented and siloed between departments. They kind of exist in different places, in drawings, sometimes in CAD files, sometimes in physical drawings, sometimes in BIM data, spreadsheets and other disconnected environments and teams that do different things with the data. And as you sure know, for now, GIS is sort of that sort of platform that brings these things together. And it's a tool that enables that CDE to be built to kind of join those different teams and silos with each other. Now, the thing is, these different teams, they have many different needs. So things like site access, for example, traffic control, security, equipment tracking, volumetric calculations, progress monitoring, indoor mapping, and these things change on a daily basis, so they need to be updated constantly. And without a shared view that brings all those kind of teams together and catering and tweaking those kind of views for different teams and different team members to view the data and monitor the data in a way that's appropriate for them to manage the project and pull this data together. You can't, again, collaborate in that in a given environment, and you cannot as well deliver that project. But also another thing, one of the biggest construction risks as well is that what we can't see, especially things that are underground, things like utilities, connection points, and safety critical assets. On-site information comes from many sources. GPR surveys, for example, utility records, sensors, CCTVs, and field observations. But without a common spatial view, we can't really have or gather the right picture of these things and how they kind of connect to one another on those different layers, the invisible and the visible. GIS brings these things together, mapping utilities, connection points, and life safety data sets as well, and makes things, obviously, this has a major impact on how projects run in terms of the speed of projects, in terms of saving costs, saving time, and obviously increasing things like safety and quality of the work that you're doing. So Esri China Hong Kong team developed this dashboard solution that supports modular integrated construction operations on a shared geospatial foundation. It starts with an enterprise GIS that hosts all the GIS data, and it starts with a dashboard that kind of shows that in real time as a big overview of the project site. But it also pulls live information, so things from cameras, things from operational databases to act as a single source of truth to bring these things together for construction teams to monitor the progress and understand the details of things on the ground. The platform integrates real-time IoT sensors and data and live feeds coming from those sensors, but government data streams as well. And this helps monitor the site conditions and things like safety, while digital work supervision systems captures field submissions from crews using survey 123 that I'm sure you're familiar with now. Live worker locations as well are tracked, so you can see, you can draw they draw geofences around areas where people are allowed to go in and out of to manage people's safety, also to have not just geofences, but time-limited fences as well for areas where people can move, but also a 3D view of the installation process of different mix, showing progress of individual modular level as it's being built, bringing again the teams a clear and up-to-date view. So this is a truly amazing example as well. If you haven't seen it before. It's basically of a single environment connecting different teams and technologies together in one ecosystem. It's basically a project that took place in Canada, in Ontario. It's basically the Ontario line, which is the major line for rapid transit corridor in Toronto. Designed to relieve pressure from the subway, the existing subway, to kind of distribute and increase riderships through that line. So deliver it means that they have to work through a dense amount of dense urban areas that are around that line that's being built. But also there's so many infrastructures, there's so many utilities that kind of in that area where they designed the road, designed the track and the railroads, and also affecting the communities that are within the vicinity or within the catchment areas of that project. Now, HDR addressed this complexity by adopting a design to construction BIM and GIS sort of approach. So it integrates Autodesk design and construction tools with ArcGIS platform. Autodesk tools support things like detailed engineering and construction workflows, while ArcGIS provides the real-world geographical context, land utilities, things like right of way, for example, and communities. Also environmental constraints as well that fall within the realm of how you analyze data that kind of falls within that area. So through things like ArcGIS GeoBIM, which is a product that's been developed again as an interface between the BIM world, between Autodesk Construction Cloud, and between the ArcGIS platform, ArcGIS GeoBIM has been used in this respect to bring together design modules and also directly link that to the location by which those things are located. So as the project moved into construction, the same connected environment supported things like progress tracking of the project by superimposing BIM on top of the GIS kind of infrastructure. But it kind of still kind of brings all and it demonstrates exactly how the Autodesk environment and the design element is sort of brought into the 3D spatial context within the GIS. And same for things with the digital delivery element of things is having the infrastructure and utilities that kind of go and fall within coming in from the BIM side of things and the 2D data side of things into the GIS world. That's an example of GeoBIM. Again, importing the BIM data, but superimposing it on the contextual environment around the world. Again, GeoBIM is a tool that kind of enables that visibility. You can do more integrations, which happened as well on this project run by HDR to integrate BIM into the GIS and basically extend the life of BIM models beyond just the construction phase into things like operation and maintenance. So for Highways England in the UK. Highways England kind of are the organization that kind of takes care of all the highways, builds highways, maintains highways, and runs projects basically on roads and motorways in the UK. So a key challenge for them during design and construction was capturing and managing all the risk hazards, the CDM hazards, what they call CDM hazards that kind of are basically hazards that occur while the construction is in place. So what they've done is they've developed a Survey 123 app and they've availed it to everyone on site. And everyone on site, kind of whoever has a list of hazard to be captured, they capture it on Survey 123, submit it with an image, with the details of the location and all that, and that kind of gets compiled into automatically into GIS, into a dashboard that is ranked according to the level of ranking of that risk in place, and it kind of is visualized and monitored as projects are being delivered. Again, here another example on a project where the challenge was understanding subsurface conditions. So particularly things or the relationship between clay layers and excavation surfaces. And communicating this across different teams is a challenge, which is why they've used the ArcGIS platform to put these different data sets and start creating a visual and spatial analysis tool that kind of enables things like visualizing, for example, the clay levels in 3D and allowing engineering and construction teams to access ground conditions in context rather than relying on disconnected records coming from different maps and different data sets. By using ArcGIS as a collaborative platform together, the project achieved improved visualization, obviously better decision making because it's real time. Everything is overlaid in a geospatial or in a proper georeference, but also it kind of reduced the uncertainty of again things like georeferencing, understanding where things are and how things intersect within the 3D space. So here's another example of another element, which is the part to do with project management integration with GIS. And this is an example of how, again, ArcGIS integrates with specifically Oracle Primavera P6 to location-enabled project management and scheduling. So by linking, again, activities and timelines to geography, the dashboards gives teams real-time visibility into where the work is planned, where it is in progress, and where delays happen on the map. Again, this helps people like planners, for example, and construction managers to make faster and more informed decisions on areas and things that they need to address in real time. Another element or another capability that you've probably heard about a lot is reality capture combined with, again, GeoAI. This is an example where GeoAI kind of supports early bid development when we're about to take on a project or bid on an RFP, and we throw in as an AEC company, and we try to examine the area. This is a really quick way to kind of extract accurate site conditions and asset counts from imagery. In this specific demo, deep learning is automatically used to identify things like solar panels, trees, obstructions and fences and things of that sort in order to assess the conditions of the site before actually being in the site. Obviously, that eliminates things like risk, elements where you could have things that you could have been shocked by once you started implementing or going into an actual project or a bid that you've won as an AEC. Now, this is an example of a site progress monitoring example using photogrammetry. So, well, photogrammetry or drone imagery and analyzing that drone imagery, which we're going to see a lot about in a minute. Where frequent, again, reality captures feed directly into those GIS boards, dashboards. But again, by moving back and forth in time, you can visually compare job progression, the status, validate things like the progress of the work. Obviously, superimpose as well BIM models, apart from scans as well, kind of helps you visualize as-built progress as it goes directly. You can, in very sophisticated ways, you can obviously automate that. But you can, I mean, as a starting point, you can visualize it and then take it another level. You can superimpose it. You can start drawing differentiations between the BIM model on site and the project as it gets built. Sorry. Okay, so I'm going to talk a little bit about reality, ArcGIS Reality. So ArcGIS Reality and the reality capture side of things is a product suite. So it's a whole suite that kind of is composed of different products inside of it. So it mainly contains 4 different products. It's a new product that we had now for more than a year. It comprises of Reality Studio, Reality for ArcGIS Pro, SiteScan, and Drone to Map. With any of these together, they can basically help you with any photogrammetrical kind of site 3D creation of the site that you're trying to collect information for. Again, you can create things like surface models, like orthomosaics, like 3D meshes, and point clouds. So when you look at the full sort of imagery workflow from top to bottom here, from the sensor side of things, we've kind of positioned the products, or we're trying to kind of like integrate the products into these workflows. Different types of products that do different functionality. Some of them do similar functionality, but depending on the environments that you want to run these things, whether being on premise or being online. Companies have their own, usually capture hardware, just like Trimble products, for example. Mostly drones in construction space, for example, and other sensors that we're going to hear about from Trimble in a minute. That imagery is processed using ArcGIS Reality, and whichever product that kind of fits best here, it kind of is suited. One of those kind of 4 products is suited depending on if, again, you want to do that on premise, you want to develop something a bit more sophisticated. You can use Reality Studio, or you want to do that on the fly. So depending on that, you could run and choose the product that you want from the Reality suite. But for starting the construction, once everything's in GIS and you want to start the construction side of things, you want to focus. We want to focus on our opportunities and things that we can use with things like, again, image server to kind of start integrating and analyzing the data, depending on, again, if it's on premise or on site. And there are a few products as well, imagery that derive kind of imagery insights, such as Excalibur and VideoServer, for example, that help you extract things out of image and analyze imagery in a way that you find is important to your workflow. Here are some capabilities of SiteScan for construction, and we can quickly look and see examples of, for example, creating things such as elevation products, cut and fill analysis, things such as volumetric comparison to the gradient surface, for example. Again, things such as integrations with ACC as well, with Autodesk Construction Cloud, and bringing data on top of the site once these type of works are done as well. So SiteScan kind of helps you do very quick, I don't want to say quick and dirty, but quick sort of analysis of that 3D model. Lets you can superimpose things on the GIS because it's all in the GIS environment, and you can quickly understand where you are in terms of the amount of time and work that is required to prepare the site for construction. We're also seeing, obviously, as you might have seen by now, that there's so many integrations with gaming engines. And you've probably seen a few demos in other rooms as well that were focused specifically on that part of what we do. Again, with ArcGIS Maps SDK, as it's available as a plugin within ArcGIS for Unity and Unreal Engine. Again, different teams, depending on what team you are and what you want to visualize, they can bring ArcGIS services and local data with premium rendering, animation, and obviously physics as well. So for construction specifically, and focusing on the construction management and site management, this works very well. So we can simulate a site. We can visualize things like where assets on the site are, where scaffolds are located, validating again things like vehicle positions and where the locations are, geofencing them in 2D and 3D. This is an example from Australia, from a company called Kimmik that kind of does exactly that. And they've used Unity and Maps SDK to build a dynamic interactive digital environment with permanent and temporary 3D that kind of, as we go, it stays permanent, stays temporary, and as the site develops, you kind of the as-built kind of stays as permanent and stays within the GIS. Now, using this, you can do things like again, coordinate different teams, so whatever makes sense, such as the construction teams in this case, for example, with the project management office, or, for example, understanding the proximity of crews to certain locations, and you can, things happen on site in real time sometimes, and you realize that certain works and certain assets are left on site in a certain location. You can quickly understand where you can mobilize different assets and different tools and different vehicles into other locations in order to run and do certain work that you need to do on site. Now, ArcGIS also now directly integrates with Microsoft 365 Power Platform and Fabric as well within the Microsoft environment. It brings, again, maps and spatial intelligence into tools that users already rely on and already work on a day-to-day basis. This kind of expands the access to geospatial frame information across the organization. So if you're using already Microsoft products and amongst your day-to-day kind of work, yeah, this kind of you can bring maps in different products such as Excel and SharePoint and Teams and so forth. So it kind of helps you very much work with GIS even as a non-GIS user within that environment that, again, might be accountancy, might be other departments that have very little to do with GIS. So I'll now kind of shift the focus a little bit onto some Esri and Trimble workflows that focus specifically on bridging that gap. Again, you have many teams across the organizations that work with survey tools. There are survey departments. They work with geomatics. They kind of reference and georeference different reality models that they capture on the ground. But again, GIS teams work sometimes in silos, and the idea here is working with Trimble closely on the global level to try to bridge that gap between those two worlds, the survey worlds and the GIS world, that kind of takes that data, does stuff with it, gives it another lease of life beyond reconnaissance, and you can get to do more and more with survey data. I'll leave it to, I'd like to introduce Engineer Mohammed Abdelmajid, who works for Trimble, based here in Saudi Arabia, and he's going to walk us through how this looks like.
Yeah, thank you. Assalamu alaikum. Thank you for attending today's session, and we are happy that we are communicating with you all. I see here in the room, there are many, many projects, and some faces I know, some faces I don't know. Let me introduce myself. I am Engineer Muhammad Abdel Majid from Trimble Field System team, and I am resident here in Middle East. So today, as Dr. Adil already started, we already have a connected workflow between us as a Trimble and between Esri and also Autodesk in the same time. So during the presentation today, we will try to focus on the workflow from starting from the field, going up to implementing that in the office. So if we go into the stages, different stages of any project exist in the market, we already have data collection, then after that the processing, then after that we have also this analysis and extract, mapping, and going into the intelligence. So how we can implement that using the existing software and existing hardware in the market. So if we are going into the existing hardware, for sure, as a project, and when we are executing, we are looking for a rapid solution. We are looking for an accurate solution, cost-effective solution, and also serve the project aspects. So starting from the handheld devices, which we are having here, I will start from left to right. So we have this high accuracy antenna, Trimble DA2, which give you some accuracy to collect the data, point, line, polygon, doing reports, and all of that. Then after that, if we are going more into the augmented reality, so we have Trimble HBS2, which will help you to superimpose your design model, bringing this from Esri or even from Autodesk into that solution on your mobile phone or on your controller, and superimpose this in the site. Then after that, you can start the augmented reality or reality capture data in the field. If we are going more into the small and the medium scale reality capture, so we have the terrestrial scanners, which can collect 1 million of points per second, and start after that you can do the process and the design and the building your BIM models for the project requirement. And if we are speaking about the large scale cities, so we are speaking about the mobile mapping system, which also can collect a lot of and huge data during you are moving on a car. This solution is mounted on a car, and I have a slide dedicated for it later on during our presentation. So this slide is very powerful for us to understand about the worldwide surveying which is done in the market. So using this solution, what we will do, we will return on investment, 96% of return on investment after you are using the solution or high technology of reality capture. For sure also, you will reduce the cost with around 50%, and also the timeline of the project, which is very effective for us. Now we have a very fast project exist in overall the world, not only in Saudi Arabia. So 10% of time reduction, and also the 7% of reduction for project costs. All of this can encourage us to implement that solutions, which is already implemented in the Middle East, and also we're still moving overall the world to make it utilize 100% on all the projects. How we are connected together? We are connected together through a CDE. So from physical reality capture, going into the enterprise asset management, we are collecting the data together. Then after that, we are putting in the same environment or same platform, and every user are using it. The engineering using it, the decision maker also using it, stakeholder using it. So that's why this is the idea, besides that, our connected workflow together. Here is the big picture. We are collecting the data using the different equipment. After that, we are going to put it or sync it to Trimble Connect. Trimble Connect is a platform which can manage and help to collaborate between all the project stakeholder, operator, engineering, all of this. And also using the API, we are also enable Esri, Autodesk, and third-party software to manipulate and put their data on this platform. After we finish all of this and we have the huge data collected from the site, we are going into the project management or collaboration or the design, all of this using SketchUp, Tekla, or MAB, even from Autodesk. All of this can use this data. And this data is very huge. Actually, this is one of the benefits of the projects. We have a big data, and we are all trying to use it. So this is a solution. You have a platform, and you can implement this platform in your project. And it's already implemented in Saudi Arabia. After we finish this, we are going again to sync this data, the design file, the collected data, the accurate designs, the accurate GCBs and benchmark into the machine control, into, again, the reality, augmented reality solution, and also even using the total station for layout and all of that. I'm sorry, because I'm a little bit far from my laptop. So speaking about just GNSS, it is not only point and line and polygon. Still, we have more to add on this one. So this is actually the portfolio of Trimble in the field or in the term of GNSS. We have HBS2, we have the DA2, which is a small low-cost antenna, which can serve in data collection. Plus also you can add your designs. You can start to interact with your office using this solution. Besides that, also we have our GNSS portfolio, which is the rugged and already accurate, which most of us know in the market and we are using in the projects. If we go to understand more or collaborate more about the interaction between the software from Esri and also from Trimble. So using the same GNSS portfolio, same hardware, it's already implemented in some organization here. They are using Trimble software. This is actually a slide or a screenshot from Trimble Access software, which is after collecting the data, you can export all of that into shapefile or even sync it to the platform. And after that, some of the people can import it back and add it to the database and all of this. Or even you can use Trimble dedicated GIS software, which is called Trimble TerraFlex. And you are importing your shapefile and start to collect the data and return it back to the CDE and start to work it in the office. Or even if I am having an ARC map or ARC field map or survey 123, I can also start to use it on my mobile or on my iPad or even in my controller from Trimble. You can do all of this. So we are integrated together. We are collaborative together. Some use cases about this, most of us are having some of this. So we are using this GNSS solution or this workflow in utility asset mapping, in the ground control, environmental, or even construction, as built, cadastre probability, wetland, and even GIS data validation, and a lot. We have a lot of samples to implement the same workflow, GIS workflow with high accuracy coming from Trimble equipment. So using the field map, it is available on Android and on iOS. So if you are having this device and also, having your device and having your software from field map, and also if you have a side vision, here, this operator having a side vision from Trimble, having his iPad, the accuracy antenna of DA2, and he started to take some sample of scanning during his infrastructure work. These samples will help him back to do the reality capture, to do the design. Sometimes we are in need for some sample of point cloud. You don't need to use a laser scanner or even a mobile mapping to have this. So using your iPad or using your iPhone, you can get this data into the platform and use it back. Same here, Same here, if I have a design and I need to implement or using the augmented reality to check this design, to check the spaces before or during the project progress and the monitoring, you can do it. This is the side vision on your mobile immediately right now. You can install this one and start to use it. Okay, just it will need some design model and after that you can implement this augmented reality in the site. For sure, all of this is already connected together. You can take a report, you can take a comment, share it with the proper person who should act on this comment or remark from the site. Here we are speaking about the augmented reality of the site vision from your mobile to Trimble controller, or even on iPad or iPhone to do some scanning. So all of these are scalable and capability for the same software, but in different controller. So this is also a reality capture. This is also a samples, and it will serve your project perspective or project scopes, which is different from engineering, from GIS, GIS, or even the BIM managers, or even the operators. We are serving a lot. Some use cases, HBS2, by the way, it has some laser, so it can be used for volumetric. It can be used also for infrastructure work, for monitoring the sites. So all of these are some use cases: GIS data, QC, and QA. Also small scale volumetric, some design visualization. Detection, change detection. If I have the design and I need to understand what's happening in the site. Also the clash detection, I can also eliminate a lot from that if I am using an augmented reality. Laser scanning. Laser scanning, this is a device. I have this photo. We have a portfolio of laser scanner. This is the Trimble X9. And it can collect million of points per second. This X9 can collect up to 1 million with range 150. This will serve in collecting the data, bringing the physical data into digital, and after that, doing the analysis, implement, creating the design, implement even the design which I have to understand what is the change. Sorry. To understand what is the change, as we see here, we have a crowded area of pipes, steel structure, and we need this millimeter accuracy. So this laser scanner exists, and it's used here in Saudi Arabia since more than 20 or 30 years. They are using the devices, especially in the oil and gas plant and all of this. For sure, it started also again to be mandatory for the building and construction. But again, it is not only a surveying. I am here today to contribute and interact with you that, okay, this is a survey solution, but we can use for GIS. We can get some data from this into GIS. And at the last slide, I will show you some real example about it. So this is our portfolio actually from Trimble. I show only one sample, which is X9, but we have also X12 with 2 million point 1 second, 80 megapixel, a lot of high capabilities or high technology to serve the different project aspect. We have also a very key player here, Trimble SX12. Trimble SX12 actually it is a total station with scanning, which is compatible with the survey workflow, and also serve the scanning and reality capture, which is needed now in the project management, project monitoring, BIM modeling, a lot of things we can do with these devices. Here we can see some use cases of this: the deformation monitoring, the as-built and the construction, topographic, heritage. Most of these are use cases, and really these devices is already served here in Saudi Arabia in different projects overall Saudi Arabia. For sure, I forget to mention here the forensic. This is also one of the important use cases with the 3D scanner, the forensic one. Okay, yes, it will save actually for safety and the monitoring of this. If we are moving to the large scale, here we have the mobile mapping, which is, I was proud that I participate in some of the mega projects here in Saudi. all the names which we are here about, like Green Riyadh, for example, and the contractor are implementing this solution. This is actually a scanner mounted on a car, and it can collect the data during movement. So we have 2 scanners. Everyone can collect, starting from 1 million. We have different portfolio in this, MX60 and MX90. And we can collect some point cloud, 2 million per second. We speak about 72 megapixel. We speak about another camera looking to the asphalt for analysis and implementing the engineering of IRI and the BCI analysis for the pavement. So this is the mobile mapping. You can imagine we can finish one district within a day, within 2 days. I already have a use case example of around 42 districts already finished in 6 months, which is very huge time saving and cost saving. It's only an operator and a driver. And besides that, it is also with accuracy. And this is the most important. We didn't neglect the accuracy. Here is another installation for the mobile mapping system on a car. So you can mount it on a car, backup, train for railway and monitoring the railway and all of this. And here we have some use cases for this, for sure, for railway, for the road and the highway. Maybe some of us see this in the market or in the road while we are driving. Yes, this is the mobile mapping for the engineering work. I like to say engineering work, not only surveying work. So if we need to get that into the connected workflow, yes, we will collect the data using the GNSS. After that, we will sync this data into ArcGIS Online. Then after that, we will publish, or ArcGIS will publish this inside Esri environment, and the different uses from the engineering and operation will do it. Or if we collect the data using Trimble solutions, then after that, we put it into Trimble Connect via the cloud. Then after that, we can use Trimble Business Center, Trimble Real Work, Tikla. All of this software also can be connected with Esri Online or Esri platform, and we start again to use. Really, this is very helpful solution, which I hope it was very implemented like that in 5-6 years back, which was the start of this mega project which we see. But again, we are here. We already move the technology forward, and we will keep moving it forward and develop it. For sure, going into the AI, the softwares, Trimble software, to don't make this presentation long, there are a dedicated AI slides about Trimble software and how it used, and how is the feature extraction automatic, how is the analysis automatic. So please reach us if you need to hear about it. So in the last few slides, I was speaking mainly about Trimble and Esri, but where is Autodesk? Autodesk is here for the BIM, for the CATs. So if we are having this kind of software from Autodesk, from Trimble, from Esri, for sure, you are connected, you are collecting the data, you are connected between the designs, between the GIS people, and also with the surveyor and construction engineers. This will help us a lot. This will help us to answer a lot of questions, to be honest. And all of this, the key here, that all we have a CDE, which we are putting and storing the data together on this CDE. Here we are speaking about the single source storing environment. So when you have a design files, when you have an Esri database, when you have a data collected from the site, so all of this is oriented our mind, because we are speaking about not only files, we are speaking about the object. We are speaking about how to use this point of high accurate collected data or even of high design files to be used in your projects. Here is some use cases between the existing data collected from the field and already drawn by using AutoCAD. After that, even the point cloud, which is collected by laser scanner and used to, for measurement or for engineering or for safety purpose, and even the movement during the mobile mapping data collection and doing the pavement inspection and all of this using the camera in the mobile mapping, all of these are use cases. And if we came at the last stage to the UAV for volume calculation and all of this is all utilized inside the 3 platform from Trimble or Esri or Autodesk. I am coming to the end, but actually this is one of the 3 slides which will show us a real case study already done. Here, I will assume I am in a company and I have the stakeholder of the project, I have the engineering, I have the surveyor, GIS team, and the CAD team. So the surveyor has already collected the data from the site. And after they return back, we process this data and we publish it on premises, on your servers, using Trimble TeamX Publisher. And after publishing this data, you will have the point cloud, you will have the images, you will have the map of the progress of your project. For sure, you can also apply some APIs to continue working on such data. But what happened after that? After that, using a username and password, you give it to your different team. They can access this data. Actually, this is a web interface. Sorry, it is Internet Explorer, Chrome. Even from your phone, you can access this. So you can imagine how many useful of this data to the people in our company. But if we came to our GIS team using a plugin, this is actually the ArcMap, and they need to open the data which collected from the field. So using the plugin, which is this plugin can be used with Esri, ArcMap, ArcPro, QGIS, Bentley Workstation, all of this, or even AutoCAD, he can open, he can start to extract some data, and this data will be synced direct inside his geodatabase or even inside the layers. So it is the same data. And with the same data also, we can use the Autodesk or AutoCAD, which is the environment. I am a CAD operator, and I need to use my software. So same plugin. I'm sorry, there are a video here. I'm sorry, Dr. Adil, can you please just please? Yeah, so this is the AutoCAD, and using the same plugin, I will open the data, and I will start to digitize some information from this data, from this huge point cloud. We bring the physical data into digital in my computer, so the whole city will come in my computer. All of this data you can use. So this was the 2 slides which I tried to show a real use case. And alhamdulillah, in Saudi Arabia, this is used, implemented. Different contractors are using it. And really, this is my slide, my last slide. And I'm happy that I was talking with you today. And thank you, Dr. Adil. Thank you. Shukran.
I mean, again, just to recap, this was a focus on specifically construction management, on seeing those 2 worlds come together, specifically linking the initial surveys with the GIS, but also afterwards as well, going back into the field again. So field, office, field. Now that kind of interaction, that kind of movement in the today's digital kind of infrastructure that we're trying to build is exactly what we needed to show today. I'd just like to remind you, if you don't mind, to kind of fill in a survey for the feedback today on the session. And also we'll be having a next session that is related again to the architecture, engineering, and construction side of things. If you're interested in room 1 at 2:30 down that end of the corridor. Thank you very much for coming today, and well, enjoy the rest of the day. Thank you.
Yep. You hear me okay? Good. Good, good. Yeah, can you hear okay? Pretty good? Yeah? Okay, good. Thank you. Yeah, yeah, yep. We'll get started in just a minute here. I've got a bunch of people scanning their code, so I figure we give them a chance to sit down and we'll get started. Welcome. If everybody can hear me okay, we'll go ahead and get started. Assalamu alaikum. Welcome. Hello. Thank you for joining me here in my little corner of the user conference. My name is Brian Keenum, and today I'm going to be talking about building a geospatial strategy on the pathway to an operational digital twin. I am a principal consultant here with Esri Global. I was a customer before I worked at Esri, so a little bit about my work history. I have about 20 years of experience with law enforcement and disaster response, emergency response prior to joining Esri. That is where I learned what GIS was, so I'm not a GIS technician by trade. I came to it from the business side and understanding through managing disasters and the systems that help empower us to manage those disasters, the power of GIS and geospatial information in making those decisions when data and information is quickly changing and you have to make the best decision that you can. And I found GIS to be an extremely useful tool for our situational awareness there. And it really shaped the way that we did responses, but also how we were prepared our assets and personnel and equipment and resources for those responses ahead of time. And it really saved us a lot of time and valuable energy and money since we're donation driven at that time to get the right places at the right time. So joined Esri about 6 years ago on the transportation team. So I spent the past 6 years working specifically in the transportation sector. I was the ports and rail practice lead globally for the past 5 years. And I've just moved to Riyadh in September to help support the regional headquarters office here in Riyadh to help establish a presence and help our strategic customers and our distributors and partners here in kind of implementing these larger scale types of initiatives. So we're going to talk a little bit about this, and ultimately, I want to say this up front, we really want to get better. Right? So please take the time after the session to go into your app and submit a survey. It won't hurt my feelings. Hopefully it won't hurt anybody else's either, but we really do want to get better. So if there's things we can do, please let us know. We like to do that. So what is a geospatial strategy? And I mean, it's a plan, right? Ultimately, we make plans for all kinds of things, whether it's planning out our day or planning capital improvement projects, planning where we're going to explore for minerals, planning for really anything that has to do with our organization. And those can be really small plans that fit into larger plans or vision, right? Vision 2030 here in the Kingdom is a great example of kind of a large scale strategy and a vision for the Kingdom. And underneath that, you're going to have a whole lot of plans and other strategies that go along with that help you accomplish that vision, right? And that's ultimately what we're talking about here. When we talk about geospatial strategies, it's no different. You're just talking about a strategy that helps you get to where your organization needs to be with regard to location-based information and data. And this can be very specific or it can be very generalized across your entire organization. It applies to anything that your organization has that has a location attached to it. And I haven't found a whole lot of things in the world that don't. And so there is a broad applicability for this type of thing, right? And so understanding kind of what you need to do in that larger vision is obviously the context in which you need to build the strategy. But really, at the end of the day, it needs to be foundationally tied to your workflows. It has to provide you return on that investment, right? Hopefully you're providing some efficiencies or savings that allow your company, your organization to do more than it was before, or to do things it never could do because of the lack of that data beforehand. And it really needs to align your data to your decision-making process on a daily basis. And that really spans from the top-level management and leadership all the way down to the end user or the worker in the field that's inputting data or doing workflows every single day. We're also going to talk about digital twins today. So it's a good idea to define what that means. You've seen probably a couple of sessions, if you've been here all day, that dealt with some of this information. We're going to go in a little bit more depth today in this particular realm, but ultimately, a digital twin is a digital representation of an actual thing, right? And again, it can be a really small digital twin that just has one pipeline attached to it, or it could be a representation of everything that you have and every asset in your company and every person in your company and all of the workflows that are in your company. All these things work together, right? So representing them together in a geospatial context just provides more efficiency and situational awareness in one place, which makes decisions more easily and more effective. So what does success look like at the end of this journey that we're taking with the geospatial strategy, creating digital twin? Ultimately, it's an integrated and operational geospatial information system. And that helps you increase your efficiency, increase your safety, make fast decisions, and have measurable return on that investment. Those are the questions that you need to answer with your GIS. So when you're thinking about the applicability of this type of work, think about these things. Do you need to increase your efficiency? Do you need to improve your safety? Do you need to make faster decisions? Or do you want to make more money or be more efficient in your operations? I find that most of the time the answer to that question is yes, 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 right? And so, and again, it really does depend on exactly what you're looking for, but most of these things can be accomplished. So we'll talk about current state. And I've learned this very painfully as a user and a business user and customer before I came to Esri. This is just about everybody. If you have any kind of data and you've started to create electronic data through systems, whether that's financial systems or operational systems, asset management, file share systems, document systems, whatever you think about, most of the time they're not very connected, right? They're very siloed. So if I need a report from someone about the performance of a particular department, most of the time I have to go to that department and ask them the question. And then they spin up a report, and that could take days, it could take hours, it could take weeks. Depends on how many people they need to talk to also, right? These troublesome data silos limit the effectiveness of the data in your organization. Your data is an extremely valuable asset. It's one of the most valuable assets that your organization have. But ultimately, if you can't access it, it's not worth anything, right? Or if it takes forever to get it, you might have to move on to something else because by the time you've asked that question and you get the report, your requirements have changed. You have to move on and do it again, right? So it really limits the effectiveness. And ultimately, GIS up until recently also kind of suffered similar types of limitations, right? It was really limited. I'd like a map of the boundary of my city. I would like a map of the operational area of this military exercise or this development project. Can you make that map for me? And a technician goes off into a closet somewhere and makes the map, right? And gives you the map. Ultimately, this is kind of how GIS has evolved. Very useful information, obviously, but when you're able to connect those things together, the whole world opens up to you and you can make better decisions. I'm going to talk a little bit more about data. Data is absolutely the foundation of any successful organization, any successful digital twin, any kind of integration platform or operationalization that you want to do with geospatial information. Your data has to be there. We can't talk about anything else until you have that data. And it not only has to be there, but it has to be in a form that can be used, right? Whether that's integrating from this platform to that platform, those pieces of information and data have to be able to speak to each other. They have to be formulated similarly, and you have to be able to access them and be able to put them on a map or in a database or in a KPI for it to be effective at all, right? So it's really important to think about quality over quantity and to make sure that you're collecting that data with purpose, right? Now, having said that, a lot of us have been through this kind of evolution where we're just collecting data kind of unbeknownst to us, right? We go in and we type something in and we save it. Well, that's data that we've collected, right? We're not necessarily collecting it to collect it and save it and use it later. We're collecting it as a part of our normal workday, right? And that's just a byproduct. The fact that we have this saved data and historical data is kind of a byproduct in some ways. What we're starting to see now is more of a recognition that that historical data or that business data is very valuable and helpful for us to understand the context of where we are, but where we can go, right? And so we've all kind of come about this maybe a little bit ahead of ourselves, but ultimately, whenever we can and we know we're going to create a new data set or collect new data overall, to make sure that we're doing so in a purposeful way and that we understand that that data is going to allow us to see patterns and it's going to become more visible and we can provide good governance around it and support our daily decisions. What does governance mean? I think about this in a different way than I think a lot of people do. There's kind of two kinds of people, I think, in the world. People that love data and would talk about it all day and enjoy integrations of data and like learn how to code and get everything to work together. And then people that at best don't care much about that or don't even like it or feel like you're forcing me to take vitamins or eat my vegetables or something. I understand both of those sides of this, and the only reason I keep bringing this up is that it is just impossible for me to express how important data is and data being available to you. So the vegetables have to be eaten. They do. Ultimately, you can get somebody else to chew them for you, but ultimately somebody's going to have to do that. So ultimately, as a manager, you need to know that data needs to be in a certain format and that it has to be standardized, right? And that you have to have organizational rules about how you put data together, how you name data, and how you retain data, and how you get rid of data, right? So there's a performance aspect to the IT systems, obviously, that you have to maintain too. Don't keep data that you don't need ever again, but make sure that the ones that you do, you're a good steward of so that you can use it in an effective way. So I'm going to talk a little bit about why data was so important. So we're going to build a data model here, okay, a digital twin. You guys, I've already mentioned, you've probably seen some sessions about data and digital twins already today, but the bottom line here is descriptive, right? And this is the base of your operation. This is literally the base map of your operation, right? So we're talking about some of the information from the Living Atlas where you have kind of a base map of data, but you're also going to be capturing imagery. You're going to be capturing footprints of assets or equipment. You're going to be creating a virtual model. And so this virtual model is really a static representation of whatever footprint you're talking about, particularly in that moment. If it's a oil refinery or a port or a rail organization or a yard. And you're going to create 2D or 3D visualizations from that. Some of these are going to be temporary. If I'm talking about a specific area of operation, if it's an exercise, that may be something you stand up and take back down later. You may not need that all the time, but it is important, especially if you have permanent kind of assets or permanent areas that you need to maintain. The descriptive part is just the absolute base, and this is where most people live today, right? Where are my buildings? Where's my roads? Where are my pieces of assets, whatever they are, right? And so that's the first thing. You got to have that. Then we move to informative. Informative, in my mind, is your enterprise data systems, right? And so those I put operations here. Operational data is your ERP data. It's your file shares. It's your GIS data, most likely. All the pieces of infrastructure that you have. And it's going to be analytics, so you're going to have some formulas and things that are in that data that allow you to understand how well you're performing from a financial standpoint, how much mineral you're producing out of a particular mine, or how much asset you're obtaining that has usable area or usable assets to generate revenue, or if you're going to be presenting that information to another person to carry it on, making sure that you have those analytics to allow them to see what the current picture is. And a virtual model which is dynamic. What does that mean? Well, that means you're taking your foundation, your descriptive model, and you're producing kind of a real-time vision of that, right? And so these business systems continue to feed your model throughout the day, throughout the week, throughout the month, and you can kind of see a today version of your foundational descriptive data, right? As you start to mature here, we can do some prediction, right? You can do machine learning, you can do forecasting, you can do simulations, and advanced analytics on the data that you're being provided. I keep saying data. It's on purpose, right? If we don't have the slide before with good governance and good data collection, we can't do this. We really can't do this, right? And so if you can't integrate data and you're not paying attention to that as you build the strategy towards getting to where you need to be, you're not going to be able to do the things that we all want to see, right? Everybody wants to see the cool stuff, and we all want to deliver the cool stuff. but ultimately data is the driver of that. Once you have good predictive foundations built, the next step is comprehensive. And this really allows you to do all kinds of scenario-based planning. So let's take real estate development, for instance. And we have a plot of land. We've built our reality capture model. We understand what that plot of land looks like, the topography of that land. We understand the operations on that land today, what utilities there are, the output, the capacity of those utilities, right? So we're starting to understand more about that piece of land. We're able to do some predictive work based on the data that we have and the scenarios that we're working through. A lot of times in a real estate development, that's a what if kind of data, right? So you're projecting what you want that piece of land to be able to provide. And then you can start doing scenarios. I have this piece of land. I have this set of constraints around that land. I need to put this number of residential units on it. I need to put this number of retail units on it. I need a hospital. I need a mosque, right? And you understand the population that needs to be served, and you can maximize the composition of that real estate development to best meet the needs of the people that are going to live there, but also to provide the most revenue and profit for the real estate developer and also the property management company that's there. See how this is building together? So ultimately the idea here, we'll take a port. You can really use this in any kind of industry. Ultimately, operations and understanding what the best land use is, what is a new capital project going to do to my environmental of the port, or the other land uses that I won't be able to do there because of that particular piece of land. That's important, right? So understanding the planning portions are really critical. Ultimately, what everybody's trying to get to is autonomous. Autonomous is a little bit of a fuzzy kind of definition, but ultimately there's different ways to look at that. Almost nobody's doing this, right? So autonomous would be, I'm getting operational data from my information layer here. I'm understanding what my forecasts and simulations and plan are, right, with that digital twin. And I'm making decisions and automatically having actions created from that based on that data without my intervention. So if we're able to do that, let's take that test fit kind of real estate development scenario again. If I give it a piece of land and it knows my business rules, my GIS system understands exactly what my constraints are, and even site-specific rules, and it can generate 3 or 4 different scenarios or test fits that would meet the requirements. That kind of stuff takes months right now, right? Your management's looking at it in a week or 2 instead, and that time equals money, right? So that's the return on investment. That's the reason you do these things. That's the reason you create these databases, and that you procure them so carefully and that you take such good care of them so that you can do those things and do things more quickly and in an informed way. And coming back to this again, right? Now you're starting to see how you could potentially get to this integrated, operationalized GIS. I thought this was a session about geospatial strategy. Well, it is, right? You have to have the end in mind to start a plan. There's a fine line and a balance to that, right? You may know part of the vision, you may know part of the destination, and you're obviously going to want to formulate a plan to get there, but you also need to remain kind of flexible enough to understand that that plan, that geospatial strategy, that digital twin, that final output, that target is going to change to some degree over time. As you gain more knowledge, a lot of us don't know what we don't know, right? So if you're not used to this kind of way of thinking or kind of the IT part of this or whatever it might be, you may have a great idea of how to run your business or run your organization or the mission that you have. But until you kind of know what's possible, it's very difficult to fully conceptualize what you need to do in life. That's just human nature, right? So we just don't know what we don't know, right? So the geospatial strategy is not only a way to get from current state to optimal state, right? Understanding that we have siloed data and manual processes and operating that and optimizing it and having a single place to look at everything. It's also a way to define what this looks like at the same time. right? So it's a little bit of both at the same time that we're kind of juggling here. But ultimately, GIS is not the goal. Better decisions are the goal here, right? And that strategy kind of bridges the gap, and you need to make sure that business value is first in your mind when you're doing this. It's very, very important. So the process of building a geospatial strategy, in my mind, has about 4 different components to it. One of them is business discovery or business meetings, identifying initiatives, prioritizing those initiatives, and then building your plan. We're going to talk about each of these in a little bit more detail. There's 100 different ways to do this. So I'm going to talk first about some cautionary tales, potentially, and then we're going to talk a little bit about what I have found in my experience to be the best way to kind of do this. The more departments, the more end users, the more workers in your organization that you can include in the process, the better the outcome is going to be, the more applicable this is going to be to them and to your organization for that matter. Having said that, there is a balance to this. You could spend 5 years doing a research project, a doctoral dissertation on all of the things that all of your workers need and want, right? So you can't do that, not practically. But you do need to find a balance, and you do need to make sure that the users are heard and the departments are heard. There's a couple of reasons for that. One, once you do this stuff, you're going to need their buy-in, right? So those folks that work for your organization are going to need to buy into this idea and take on these workflows and understand that that's why the organization is doing it and the direction they're headed, right? So ultimately, the way we've done this in the past is we'll meet with each department, and you can kind of break that down into whatever level you need to. If it's 10 meetings or 50, it really doesn't matter, but ultimately you've got to take the time to really sit down and hear them. And you're going to listen to, it's just a really being interested kind of environment. Like I just sit down and say, well, tell me what you do. Most people are happy to tell you what they do. They like talking about their work. People do work because they like it and they feel fulfilled by it, and they like sharing that with people. So what do you do on a daily basis? Oh, that sounds interesting. Like, and what's the hardest part of what you do? What are the things every day that drive you crazy, that are frustrating, right? What keeps you from being able to do your job well? What are the pain points? Once you focus on users and identify the pain points, you're going to balance that, and this is going back to the balancing to this. As a management structure and leadership, there's a certain level of information and data that they're going to need to do their job well too, right? And that's going to be different and maybe sometimes conflicting with seemingly what the workers are doing on a daily basis, right? But you need both. You've got to have both. So you have to understand management's needs and what their reporting needs to be so that they can do what they need to do on a daily basis. Listen before building. Kind of covered this, but that makes a lot of sense, right? So you want to hear them, and then you're going to want to make a plan afterwards. So throughout that process, you're thinking, okay, I'm hearing their pain points. I've got this idea that I want to streamline these things. I want to make them electronic. I want to put them on a map. I want to build a form or a survey or something, and to help them out. And how can I do that? How can I do what I need to do, but also accomplish or alleviate the pain that these guys are kind of feeling every day in their daily work? How can I make their job easier? Going back to the change management piece, the adoption piece later, if it's not making their job easier, it's going to be hard to get them to do it. We're all too busy. We all have too much to do, right? I don't think there's anybody in here that would say that they need more work, right? So when you come down, or somebody that you work for comes down and says, we're going to double entry this data into the system that we bought, but we're also going to double enter it into the GIS system. Well, not only are they going to be resistant to that, but if they do it, probably not going to be 100% of the time. So what do you have? Bad data. You got no foundation. So the information that is built into this digital twin, into your operation, and into your organization is not going to be reliable, right? And it's not going to be helpful, and it's going to die, right? Like the solution will not prosper, right? And that's ultimately what you're looking for. you want it to prosper, but you also want to make the work easier and better, right? So that you can do things that you never could get to before. We've all got that too. So once you've gone through this process, speaking with the departments, you're going to be identifying the geospatial initiatives. And you can call that whatever you want to. These are going to be GIS apps. They could be projects. They could be whatever. I think a lot of it depends on the scale of what that particular thing is that the organization will need to make those pain points go away and streamline that workflow. But it needs to be aligned with the organizational goals. If it's going left when you're going straight, then don't do it. That's not helpful either, right? You need to make sure these things are aligned to your organizational goals, the goals of your manager, the goals of your department, whatever you're focused on, it needs to align with that. It should help your department, your users. Already said this. It's very, very worth saying over and over again. The data needs to be available, right? Ultimately, if you want to build a visualization today with KPIs and understand the analytics of particular pieces, understand the profit and loss of a particular site, you got to have the data for it. If not, you got to have a plan to capture it. And I would suggest putting that one to the side for now while you get the data and bring it back into this project, this roadmap, once you have that data, right? And it has to be achievable. And I think there's 3 elements to that I've listed here: people, processes, and technology. Technology is probably the easiest one of these. With enough money and enough time, you can do just about anything. It might take a long time, but technology can likely be overcome, right? The processes, oftentimes this is part of the difficulty, and the processes have to be rethought a little bit. We've all done things a certain way. It's manual. I take this checklist, I put it on a clipboard, I go out in the field, and I do this inspection. That's what I do. I don't want to put it in a computer. I've never done that in my life, right? So the process has to change, but as you notice, I discovered the process and articulated it to you through that person, that user's experience. The most difficult part is the people part. I think we can all identify with that too. In most things, the most difficult part is the people part, right? And so you have to make sure that the people want to do it and they can do it. If they can't, it may be because they're not trained to do it and they just want some help and training. We can do that, right? That's the kind of thing that needs to go into your thought process about how you're going to roll this out so that you can keep everybody on the bus as you drive forward and on this journey. We've talked about elements of this, but prioritizing those initiatives. So we've put it through the filter of can it be done and should we do it based on our organizational goals and strategies. But now we're going to prioritize these. What are we going to do first? What's the roadmap going to look like? And what order is it going to be in? Well, there's kind of 2 different pieces to that. One of them is business value, and the other one's level of effort, right? And there's some sub-bullets to those. I already mentioned those to some degree. That they've got to be aligned with your goals. Some are going to be more aligned than others. It should help people. It should help the people from the bottom to the top of that workflow. You know, the people that take the data and move it up the chain for approvals all the way to management, understanding the KPIs that management needs. All of that has to be part of this. And it really should help streamline a process that they're doing on a daily basis or a new process that you know you have to undertake for compliance reasons or operational reasons or what have you. Level of effort, data is probably the longest tail, right? If you don't have the data, you've got to find a way to get it. And ultimately, you could build an app that starts a new inspection that you've never done before. Yeah, that's pretty easy, you know, because you're not coming into it with dirty data. You just have none, and that's often better. So you can kind of build this closed loop and start building data as you go with that level of effort. So technology is available. Again, it may take time. We're not quite there yet with this piece of technology. We know in 6 months or a year it will come through, right? And so we'll put that off till then, but that needs to go into your calculation. And how long and how hard is it to build the thing, right? And that really comes down to the complexity of the workflow applied to the technology to get the product. And you have to understand that. So putting this in practical terms, I've typically gone through a process where I'll have the business give a value score to that particular app or initiative and say, 1 through 5, 5 being the most beneficial to the business, 1 being the least beneficial to the business, and have 3 people do it, or 3 or 5 people do it, right? So you can average those scores out, and you're not getting biases from individuals and those types of things. Makes it a little more scientific. And then same for the level of effort, and usually that comes from the people that will be building the solution. Again, 1 through 5, 5 being the most difficult, 1 being the most easy to make. And you put them on a graph. Obviously, you want to start with the things that take the least effort and have the most business value first. So this geospatial strategy, this path towards operational excellence begins in a logical way, and you kind of understand where to go from there. And again, there are different kind of things that kind of influence this that you have to pay attention to. That brings us to the final piece here. Create your strategy. You're going to build this roadmap, this journey based on the initiatives that you've prioritized. And I just put these here again, aligned with your organization. So you have, make sure it's with your organizational vision. Make sure it also aligns with the other roadmaps in your organization, your IT roadmap, right? If it's not something that they can support, work together and figure out when it can fit in, that's going to play into this, right? It'd be good to get them involved early, not at this point. So, but understanding what the roadmap of the organization looks like from other perspectives is good. Do data governance workshops. Just build a governance structure in your organization. And that doesn't just apply to geospatial information. That's everything, right? So IT should have a data plan. They should have a data governance plan. And you can contribute or we can help add or whomever can help add the geospatial components of that so that it aligns with that vision that's already there. Or you can help them create one. This could be the example that the rest of the organization and your IT infrastructure and your staff use to build their own data governance structure that's outside of whatever's geospatially organized. And then we talked about organizational governance a little bit throughout this talk, but what does that mean? Essentially, it means making sure that your people are aware, that they're bought in, that they're trained properly, that you have good communication about not only that we're doing this, but why we're doing this, so they understand, so they'll want to adopt it. And a training plan is often part of that, but I did list it separately because it is an intentional effort that needs to be undertaken. So giving you a concrete kind of feel for what a strategy might look like at the end. This is an example of kind of a departmental view. So think of this as one of those meetings or one meeting with several parts of an organization that are rolled up to a larger bureau or department. So what we do is talk about, obviously, we want to show the level of effort. How many meetings did we have? Who do we meet with? We're going to talk about the different patterns of use within that department. We're going to talk a little bit about what the department does. And then we're going to have notes from the meeting, some of the high-level patterns that came out. And then potential work products are those initiatives at the bottom that we then can understand and prioritize. Once you've got all of those, we would typically do this with each department or each larger, business unit. You can build your plan. You can build your roadmap and understand what you need to do. So you may have a 6-month period. You may have a 1-year period and then 3 to 5 year period. So as they build together, you understand what you're undertaking when. And this also allows you to go back from an organizational standpoint and understand what level of investment you're going to need for each of those periods, right? So the next 6 months, we're going to need $300,000. Over the next year, we're going to need $1 million. Over the next 5, we need 3, and we'll get it done, right? Kind of idea. And the idea is also that these are iterative tools. So going back to that maturity model, when you're going from descriptive to autonomous, you're not going to build linearly necessarily all the way across. You may have your base map completed, but you're also able to then build apps that integrate data from that descriptive layer and bring it all the way up into the kind of comprehensive or predictive layer as you build. So you're doing iterative kind of sprints. And the reason that's beneficial too is that no leader, no senior management team wants you to come into their room with a project idea that says, give me $5 million in 5 years and I'll come back with something awesome, right? People want to see results right away, right? And you want to provide results right away. We all want to do the best we can for our organization. So this type of development cycle allows you to show results early and iterate on those results and build and start to build up the chain and build out as well. So that's something else you're taking into account when you do this. Nice reminder, after the fact, we also have historically distilled it down into a one-page plan. This is more of a kind of strategic document, a higher level. Ultimately, it allows folks to understand where they're headed at any given time. It's easy, at least in my experience, to start a project and start a little app, or you're building something and you kind of get into this little tunnel and you're not really thinking about where it fits into the organization. And that can lessen motivation over time, potentially, especially if you have difficulties or roadblocks along the way. So this kind of gives you a guiding light, an idea of why we're still doing this. That just reminds me why I'm doing this thing today that's really difficult. I'm making my organization better, and this is how, right? And so ultimately, having this one-pager is a good way to do that. It's an easy way to do that, and that's the idea behind that piece too. And again, what we're driving for here is increased efficiencies, increased safety, faster decisions, and measurable ROI through an integrated and operationalized GIS system. I'll remind you to do your survey. And we've got a little bit of time. If anybody has any questions, I'm happy to take them. I will have to repeat them so people that are watching online can understand what I'm talking about. Otherwise, it's going to be kind of funny. But I'm happy to take some questions if anybody has them. Go ahead. I think you started. So. Yes. Mm-hmm. Yes, of course. Yeah, that's a great question. So, yeah, so the question was, how do you develop quick wins, right? A lot of times you go to a leadership meeting and you've developed this project and you're so excited about it, and they're like, well, that's great. We'll give you some time, but we're going to need something in 3 months or 6 months to show people that this is going to work, right? This is exactly what I'm talking about, that balance between business value and level of effort, right? And so if you've done a good job in identifying the real things that are needed in the organization, you're going to start with the things that are the most business value, that are the least level of effort. Those are the quick wins. Those are the ones that would take a month or 2 or 3 to show quick value. So let's take a little bit of a practical approach to this question. You have a parks department that you're working in, right? You're responsible for planting trees. You're responsible for creating this park and then maintaining this park. And up to this point, you've had restrooms in there, but nobody's looking after them very well, or they're very manual. You go in there, you see something wrong, you tell somebody, and they go fix it. And this Parks and Rec department wants to see some digital twin. They want to see some representation of this operation, and they want to see something that's going to wow them early. Well, number one, the foundational pieces that I talked about, the imagery. Let me actually go back to that. The imagery that is involved in that base map, the topography, the imagery that goes over buildings and your building footprints, that descriptive piece that we started with. This stuff is relatively quick win, right? So a lot of times, if you don't have a lot of geospatial or GIS footprint to begin with, that's a big wow. That's a quick win. Those are big wow things. People see something on the map for the first time and they're just blown away. Your organization may be past that, completely understood, right? So what can you do to that? Well, the next thing for you to do is show real-time information about where your trucks or your people or your assets are in relation to that base map. That's another big wow. And I'll be honest with you, putting an API together for vehicle tracking, for instance, is an afternoon job. It's not difficult, right? But it's very impactful. So when a manager looks at that, they say, "That's my truck now? Wait, I just saw it move." Right? This thing's refreshing every 2 minutes or every minute. It's incredible, right? And it is incredible. But from an IT perspective or a development perspective, it's very low level of effort. So those are the types of things that you think about. I was getting to the bathrooms in the park, and that is about an inspection form. Understand the real-time condition of that that bathroom, even if you got to the point where somebody could push a button on the way out that says this thing needs to be cleaned, it comes up on a map and it says, go clean this thing right now, it's in bad shape, right? That's instant. That's a quick win. It's not a technically difficult problem, as long as you have a kiosk or something in there for them to push that's electronic that gets it back to you, right? It really depends on, it's a hard question to answer from a specific standpoint, but those are the types of things that I think about. Anything that's in these first two kind of levels are relatively easy to deal with from a technical perspective. And honestly, they're the biggest wow if you don't have them already, right? When you get up to these things, it's really cool to see scenarios. And people will need that once you get these things because they're already trained to this. They already know that this is there, right? So the next wow is actually doing scenarios. But the quick wins are kind of at the bottom of the foundation, depending on where you are. It's a good question. Thank you. Go ahead. Yeah, absolutely. Okay. Yeah. That's a good question. So from an analyst perspective, what you need to do is get a champion, right? So from an analyst perspective, it's a difficult position to be because a lot of analysts, a lot of GIS workers, folks that work with this stuff on a daily basis, they get it, right? You walk around here, you go through the map gallery, you see the maps and the things that could be created, and you're like, yeah, I know. I mean, this is beautiful, but I get it already. Tell my boss or tell my executive or tell the manager or the leader of the organization. That is the hardest part of all of this. If you're not at that level already, if you're not the executive champion, it's very difficult to get that. I would almost tie it back to the quick wins. Even if it is a proof of concept that you can develop on your own as an analyst to show your leadership what's possible. Usually the difficulty in getting a champion or somebody bought into this type of prioritization is because they're not able to conceptualize what's possible, what's available. It's not us that already conceive of this and see the world in the way that we do as a location-based entity. They're not thinking that way, right? So they've got a different way of thinking. They comprehend the world in a different way. It may be very linear. It may be, it might very well be my spreadsheet. My spreadsheet that I'm responsible for, I need this to be right. And that's the way I look at my job. It's the way I look at the organization. The organization feeds my spreadsheet, right? So you've got to take them out of that dynamic and show them a different way. And ultimately, again, going back to the bottom tier here, reality capture or showing them where their footprint of their buildings are, amazing, right? Showing them a form that they can fill out instead of having to compile 300 sheets of paper, huge. Showing it to them on a map, here's your list, click on that, and it'll show you the whole inspection. So oftentimes it takes some initiative just to build something on the side that at least conceptualizes it for them, and not a paragraph, not an email, because it still requires them to be able to bridge the gap between what you're saying and what they're going to see, right? Ultimately, you're going to need to show them a tool or show them a picture that really lets them know what the advantages are that they're not seeing already. What I found, I think very specifically about somebody I work for at the Red Cross and our disaster operations. So we operated every day at 4 a.m. We'd compile this report. It's about 50 pages long. It was a PDF of all of the things that are going on. What's the weather like? What's our operation look like? The people on the ground, how many people do we have there? Where are emergency response vehicles today? That was a snapshot at 4 a.m. that was no good for the rest of the day until the next day at 4 a.m, unless you called somebody and said, where are you? And so the difficulty was that the people that were in those decision-making positions had been doing it that way for 15, 20, 30 years, right? And so they're very used to that, very comfortable in that, and they can't even really see the other way to do it, right? And so ultimately, we did have a leader that was at least visionary enough to say, well, let's figure out what else is possible. Like, go look at things and tell me what we can do to make this better, right? And that really is where we started on our journey to make this operational picture. I'd say the most impactful thing we did was building a map where you could draw a polygon of the disaster response area and building an API for our emergency response vehicles so you could see where they were and they were positioned and supplies and those types of things and where they were in the context of this operational zone. And then our partners also in that response could do the same thing. And it was just completely mind-blowing to the people that were in our leadership and doing disaster relief management. And what I found at that point was we couldn't keep up with the requests anymore because they started to see things in this way and they understood the potential and the things that could be done. And they're like, oh, we'll do this, this, and this, and this. We need this in there. And why isn't this in there? And we should do that. So once it clicks, it really clicks, I think, ultimately. But it is the hardest part of this entire journey is to do what you just said, and that is get them to think differently. But usually it takes a little bit of a sample for them to do that. And that's ultimately something that Esri and the distributor here of Saudi Arabia can help with also. It's not something you necessarily have to do. And we've all got full-time jobs, right? But we can help with that too. Any other questions? Thank you for the time. I really appreciate it. Thanks for being here. Have a good day.